Okay, everyone, Assalamu alaikum. I hope you're all well. We are going to start. So today we are not going to be doing any specific paper as such. It's just going to be you asking any specific questions that you might have from past papers on any particular topic. If there's any concept that's still troubling you that you want to ask about, you can let me know about that. That's the plan for this particular class. Okay, so let me know any problems that you might have. We could discuss them. So we've had the revision session already on Saturday. We have covered, uh, we've covered, we've gone through all the concepts that we need for the exam. We've done so much practice, past paper practice, and also topical practice before that in the crash course session. तो अब बस final अगर आपके कोई questions हैं तो this session is just for that. If there's anything that you want to ask the day before the exam, let me know. Overall जो है आज की class अब के बाद से I would not really recommend that you do any more past papers from now on. Just make sure that you revise everything that you've done until now. First of all, make sure you revise the concept, spend maybe a couple of hours on that, going through your notes. Make sure that you have covered all the detail, and then look at the past papers that you've already attempted before. And if there were questions that you got wrong the first time, if you want, you can also review them. In fact, you must review them as well, because you need to make sure the concepts that you got wrong the first time, you now understand them well. So revise your concepts from your notes and also go through all the questions that you have already attempted before. Do not attempt many new questions at this point. It's just like less than 24 hours to go before your exam now. You don't want any extra pressure now. Okay. So let me know if you guys have any specific questions. Variant 1-3 was easy. Yeah, so generally what happens is two variants are generally relatively easier. Not easier, but दो एक जैसे होते हैं और एक अलग से होता है. For example, if you either have two easy and one hard, or you have two hard and one easy. So 1-3 easy होने से you cannot say anything for sure about 1-2 कि ये कैसा होगा. It could be anything, it could be hard, it could be easy. So उससे हमें इसके बारे में कुछ पता नहीं चल सकता. Normally 2-1 होता है, 2 easy 1 hard, 2 hard 1 easy. तो it could be anything. We can't say about it. Differentiation के लिए आपको वॉल्यूम और सरफेस एरिया के फॉर्मूलाज बिल्कुल आने चाहिए. You need to know all of those formulas. The formulas for sphere, pyramid, they are given in the exam, but the rest of them you need to remember. Mensuration may be one differentiation. Where did that go? So these are the formulas that you would need to know about. The volume formula is primarily because surface area you can figure out yourself. Looking at the number of faces that you've got, you just find the area of each face, add all of them together, and that gives you the surface area. For volume, the last three, they will be given in the exam. 1/3 pi r square is for cone. Pyramid ka formula, half into base 1/3 into base area into height, or sphere 4/3 pi r cube. These four you need to know. They're fairly straightforward as well. Volume of cube, cuboid, cylinder, pi r square h, and prism. And that's it. These are the ones that you need to remember. Okay. How to address restrictions and roots in an equation where one root is not possible. Whenever you get multiple roots, always look at the question statement and see if there's any root that the question statement might not allow for some reason. For example, the question might say the value of the unknown that you're finding, it has to be positive, or any other thing like that. whenever you get multiple answers, always check the question statement. Also, the question statement is very exact generally. So if the question says something like this, give your answer to a certain number of decimal places. Now, if it says answer, it's a singular, it has to be one solution. You cannot have multiple solutions. So look at the question statement as well. That also gives you a hint. If they're using a singular for answer, that means that there has to be only one answer. Then you look at whatever the statement says about the solution, whether it has to be positive, it has to be negative, or it has to be in a certain interval. Maybe at some using one of those values, the function becomes undefined. Anything like that, you would just look at that and ignore one of the answers based on that. So whenever you have multiple answers, always look at the question statements to see if there's anything that is not possible. Okay, I'll go through that. Increasing, decreasing functions का मैं अभी उस पे भी देखता हूँ. Yes, for today I'm reading these charts as well on YouTube as well. Let me quickly have a look at this as well. Okay, so there are two things that you want me to discuss. Okay, so one is area between two graphs, and the other is how to prove a function is increasing or decreasing. Okay. All right, let's have a look at this. Area between two graphs. ये कैसे figure out करते हैं? Let's say you have something like this. You have two functions. One is this, y equals 9 minus x cube, and the other is this, y equals 8 over x cube. In the shaded part, you see which is the lower function and which is the upper function. In the shaded part, the blue one is the lower function, the green one is the upper function. What you do is you integrate each of them separately. That's one idea. Upper function, you integrate that, input its limits 1 to 2. Then you integrate the lower function, integrate that with limits, and you get a result from that. And then you just find their difference. So the shaded area would be area between the upper curve and x-axis and area between the lower curve and the x-axis. Just find their difference, and that will give you the result. If the limits are the same, for both of those graphs, for example, in this case, the limits are the same. It's going from 1 to 2. In this case, you can also do it like this, that you say, subtract the functions first. So this is one idea, that you evaluate these two integrals separately for the upper and lower function, and then you just find their difference. That's one idea. The other idea is that you first subtract the functions. If their limits are the same, you first find their difference, then you write it as a single expression, integrated input limits, and you would get that area directly. This also works. Okay. All right. Then you have increasing and decreasing functions. Increasing functions are those functions that have a derivative that is positive, that have a gradient that is positive. So increasing functions are when the gradient is positive, Decreasing functions are when the gradient is negative, right? Now, some functions are always positive, always negative, always increasing, always decreasing. For example, the functions on the left side that you see here, these are always increasing. ऊपर की तरफ जा रहे हैं, their gradients are positive. And the other ones on the right side, they are decreasing. They're going in the downward direction. Right? They're going in the downward direction. Now, how do you prove if a function is increasing or decreasing? How do you figure that out? You find the derivative. For example, you have this example here, 2x minus 5 whole cube plus x. You need to show that the function is an increasing function. What you do is you find the derivative. The derivative, if that turns out to be always positive, that means this is an increasing function. So we find the derivative of this, The derivative in this case turns out to be 6 minus 2x, 6 into 2x minus 5 whole squared plus 1. Now you see 6 is a positive number. 2x minus 5 whole squared, that is a square. A square can never be negative. And then outside as well, you have plus 1 here, and that is also positive. So that means since this first term is always greater than or equal to 0, the second term is 1, that's also positive. The overall expression is always going to be positive. Now, the examiner is not going to require you for a detailed explanation for why this is positive. Once you have written this expression down in a form from which you can logically think that this is always going to be positive, you just write down this statement that the derivative is greater than 0. That is why it's increasing function. On the other hand, you could end up getting something like this as well. When you find the derivative turns out to be this. In this case, the derivative turns out to be, so we have this function, y equals 1 over x cubed minus x cubed. We have to show that this is a decreasing function. This is a decreasing function. How do you show that? Again, you find the derivative for this. Derivative turns out to be this expression. And now you need to think about how this derivative is always negative. One way to do this is you say, okay, let's take minus common outside. Inside the expression, then you're left with this 3 over x raised to power 4 plus 3x squared. What does that mean? This expression is always positive because you have 3, that's a positive number. In the denominator, you have x power 4, that's a positive number because even powers can never be negative. And the second term that you have here, that's 3x squared. Again, 3 is a positive number. X squared is supposed to be positive. Both of these are positive. So we have a negative number outside. This whole thing is positive. So the overall result that you get from this is minus into positive. That is going to be negative. That means it's a decreasing function. Now, this function is always decreasing. This function is always decreasing. The previous function, this was always increasing. This was always increasing. So in no scenario would this be a decreasing function. It is increasing throughout. It's a cubic function. This cubic function would actually look something like this. It would be a shape like this. So it's always increasing like this. It's always increasing like this. B square minus 4ac, that can be used for this as well. So that's going to be very confusing. I would actually recommend against that because it's very likely that you would end up not arguing that correctly. So I would actually recommend you to refrain from that. Just use the minimum point. That will be easier to do. Okay. For example, if this is the derivative, you show that this is always positive because you could think of it like this as well. The minimum value of this derivative is 1 because it's a U-shaped curve, this one, the curve for the derivative, and it has a minimum value that is at 1. Since the minimum value is 1, that means it is always positive. Okay, it is always positive. Achha, function transformations. Let me come to that. Function transformations. Let me come to that quickly. Walaikum assalam. Function transformation देखते हैं. Function transformations में the order has to be this. This is extremely important. Recent questions in this are sometimes quite tricky. Order of transformations. When you have horizontal and vertical transformations, that means some horizontal transformation, some vertical transformation. Between horizontal and vertical, the order does not matter, right? So, for example, if you have something like this, 2 into f of x plus 3. Now, this is a vertical stretch. This is a horizontal translation. One is vertical, the other is horizontal. Between them, the order does not matter, right? It could be any order. You could do the vertical first, you could do the horizontal first, it would not matter. But when you have multiple vertical transformations, for example, you could have something like this, or you could have something like this. Now, these are both vertical because the operations are being applied outside the function. F of x के बाहर कुछ ना कुछ multiply add हो रहा है, right? Not inside. Now in this case, when you have vertical transformations, multiple vertical transformations, the order is whatever BODMAS is, right? Whatever BODMAS is, that's the order of function transformations, okay? BODMAS. Now, what does that mean? If you have minus 2 into f of x plus 7, what BODMAS says that you should be doing multiplication first, right? So that means stretch and reflection, they will happen first. Between stretch and reflection, it doesn't matter. Both are multiplication, so they are both going to have the same priority. But then the second comes translation, because that's what BODMAS says. You do multiplication first and then you do addition. For an expression like this, again, these are vertical transformations, but now you have an extra bracket added there. You have this extra bracket. When you have this extra bracket, what does BODMAS say? BODMAS says that you would be doing plus 7 first. This will be evaluated first. So you do translation first, and then you do stretch after that, right? So in vertical transformations, you just follow BODMAS. In horizontal, however, it becomes a bit more confusing. In horizontal transformations, you have to do the opposite of BODMAS. Whatever BODMAS says, you do the opposite of that, okay? In horizontal transformations, you do the opposite of BODMAS. Okay? So if you have f of minus 5x plus 3, f of minus 5x plus 3, if you have this, what does that mean? BODMAS says you do minus 5 first, and then you do plus 3. You have to do the opposite of that. So you do plus 3 first, that means you do translation minus 3, 0 first. That's the first thing that you do. And then stretch or reflection, you can say with a scale, it's a stretch with a reflection, with a scale factor of minus 1 over 5. That will be the second transformation that you do. But then in horizontal, when they have an extra bracket like this, when you have an extra bracket in horizontal transformations, what about this now? Again, you have to do the opposite of BODMAS. Opposite of BODMAS. BODMAS says that you should be doing plus 4 first. You should be evaluating the bracket first. You do the opposite of that. No, you say do this first. You do stretch first in this case. So stretch reflection, that happens first in this case, and then you do this plus 4. That will be the opposite of BODMAS. So in vertical transformations, you follow BODMAS. In horizontal transformations, you just do the opposite of that. How do you follow order of multiple brackets? I'm not sure if I understand what you mean by that. So we have multiple brackets here, like, right? This is what you're saying? Before the exam, please don't do any past papers. Today, maybe if you want to review some of the past papers, do that. But tomorrow morning, I would recommend have some. Do not wake up at 8 in the morning so that you are tired by 1 p.m., 2 p.m. Have some sleep in the morning as well. So if you're an early riser, if you are not going to sleep after Fajr, I would say have a 1 hour nap before the exam as well, as in not just before the exam, but maybe around 10, 11 a.m., 9, 10 a.m. If you wake up late, as in you'll sleep after Fajr, hopefully you'll pray Fajr and then you'll sleep. And then after that, if you wake up at like 9, 10 a.m., that should be fine. Then you can maybe have a quick revision of your notes. Just skim through the notes, not very detailed, and that's it. कल आपने बहुत ज़्यादा स्ट्रेस नहीं लेना. PM exam का ये मसला होता है, if you end up studying too much in the morning, then you are already tired by the time the exam starts. You don't want that to happen. In a math exam, it's extremely important that you're very fresh. Otherwise, you would be doing careless errors, and that's going to be much more costly than those 1 or 2 marks that you might, end up gaining by that extra revision or extra practice that you would be doing in the morning. that's not worth it at the end. You want to be fresh for your exam. You want to be very fresh for your exam. Okay, so all right. So in this example, as I said, it's two horizontal transformations. It's two horizontal transformations. You have to do opposite of BODMAS. BODMAS says that you do +4 first. You do the opposite of that. You say you do this first. So you do stretch reflection first, and then you do translation. In this case, in horizontal, you have to do the opposite of BODMAS. Okay. Okay, Abdul Hadi, let me come to that. Let me come to that. Okay, one last example in this. So somebody asking about this. F of 2x plus 8 and f of 2 into x plus 4. Are they the same? Yes, they are both the same. They are both the same. If you have this, if you want, you can convert it to this and then write down the transformations. That's also fine. अगर आप इनके अलग-अलग लिखते हो, you can write it like this. You would say this is a translation. This is horizontal transformations, right? You do opposite of BODMAS. So you do translation first, -80, and then you do a stretch. It's a horizontal stretch. Horizontal stretch scale factor 1/2. This is one possible description of this transformation. If it was written in this form, this could also be written as that it's a horizontal stretch. It's a horizontal stretch with scale factor 1/2, right? Because opposite of BODMAS says that you do this first, you multiply by 2 first, and then you do translation after that. In this case, when you do translation, the vector is going to be -40. Now, if you do stretch first, then the translation vector is going to be -40. If you do translation first, then the translation vector is going to be -80, and the stretch is going to be with a scale factor of 1/2. Both of these are correct, right? That change in order basically takes care of this difference in the vectors that you have there, right? जब आप order change कर देते हो, उससे वो translation vector भी change हो जाता है उसके according. All right. Okay, I hope that makes sense. There was another example in this. Omar, you don't talk about teachers like that. Similar triangles, yes, you can get similar triangles. You do get similar triangles, which you might have to use in some mensuration part that you might get with the question. You may have to use that. Yes, anything in O levels that you've done, it can show up somewhere because Cambridge assumes that you have reached here after doing O level or IGCSE. So yes, something can come up from there. That is totally possible. Question 8, part A from paper 1/1, October, November 24. Abdul Hadi, can you please do me a favor? Can you please send this to me? Send a snapshot of that on WhatsApp because there's some problem with my OneDrive today and I cannot access any files for some reason. There's a problem with the OneNote notes for that reason today as well. I thought it got fixed, but it's still causing problems. I can't access my papers here. So maybe take a snapshot of that and send that to the WhatsApp group and we'll have a look at that. Acha. Circular measure, why is that a problem? Circular measure. 15 yearlies, 15, does that mean 15 years of papers or 15 yearly past papers? Either of them, that's sufficient practice. You have like 18 hours to go now. There's not much more that you can do at this point. Just revise everything now. Just revise everything now, and especially go through the questions that you got wrong the first time. Can I do May June 2025 paper 1-3? Unfortunately, that would not be possible right now. I can definitely not stream that because I would get a copyright strike right away from Cambridge. That's not unfortunately possible. Gee, Abdul Hadi, have you sent that question? Let's quickly do that. Okay, so it's not very clear, but I will just copy that anyway. Let's do that. Volume questions, you have to be specific. Tell me know the exact question that you want me to do. Volume questions in general, you can find a video for that. Volume of revolution questions. If you have a specific question that you're having problem in, you can share that specific question. Okay, so you're saying it's given that. What I do is just copy this so we don't have that working there. Oh, so this is what you might want me to solve. Okay, let's try this. It's given that beta is an angle between 90 degrees and 180 degrees such that sine of beta is equal to A. Express tan square beta minus 3 sine beta cos beta in terms of A. Okay, so one possibility is that you use identities, but this is done much more easily using a right angle triangle. It's an obtuse angle, right? It's between 90 degrees and 180 degrees. Now, what does that mean? In which quadrant is it going to be? In what quadrant is it going to be? This is going to be in the second quadrant. This is Y, this is X. Let's represent it somewhere here. Let's say this is the origin. Let's make a triangle in the second quadrant here. They're saying sine of beta is equal to A. Sine beta is equal to A. Now, how is sine defined? Sine can be written as perpendicular over the hypotenuse. So we have a triangle in the second quadrant here such that this angle is beta. And this is the basic angle here. In this right angle triangle, the perpendicular that and hypotenuse, what's their ratio? Their ratio is A. Okay, what does that mean? If that's the ratio, we can say A over 1 is equal to perpendicular over hypotenuse. So if perpendicular is A, then the hypotenuse is supposed to be 1. Then what is the base going to be? Base squared plus perpendicular squared, that should equal hypotenuse squared. From this, you get base equal to 1 minus A squared and square root of that. So in this right angle triangle, now you know what the three sides are going to be in terms of their ratios. If hypotenuse is 1, the perpendicular is supposed to be A and the base is supposed to be square root of 1 minus A squared. And now you can just input values in that expression that they gave us. Tan square beta minus 3 sine beta into cos of beta. Now this is the second quadrant. Keep that in mind. It's the second quadrant. In the second quadrant, sine is positive, but tan and cos are negative. Tan and cos are negative. Okay. Since tan and cos are negative, you have to write their negative values. I can just write them on the side here first. Cos of A. What is that? That's base over hypotenuse. So that will be square root of 1 minus a squared divided by the hypotenuse, which is 1. But then you put a negative sign with that because this is in the second quadrant. Tan, what's that going to be? That's perpendicular over the base. Perpendicular is a, the base is this. So that's a over square root of 1 minus a squared. And then again, since it is in the second quadrant, we have to put a negative sign with that. Okay. Now you just have to input values here. Tan of beta. I'm sorry, that was beta, not a. Tan cos of beta is this, tan of beta is this. So now we can say tan square beta, that will be minus a over square root of 1 minus a squared whole squared minus 3 into sine beta. What's sine beta? Sine beta is a into cos beta. What's cos beta? That's minus square root of 1 minus a squared divided by 1. Right? Or just this. This is your cos. Now you just simplify this, you get your result. This gives you a squared divided by 1 minus a squared. The minus gets eliminated because we are squaring that. Minus 3, and this, we have this minus as well, so it becomes plus here, plus 3a into square root of 1 minus a squared. This is what they were asking for in terms of a. They've not really said that you need to simplify this as such. So you can leave it like this as well, and that will be okay. That's your final result. Is that okay? Any problems with this? Guess paper, Mursal? There's no guess paper. Guess paper, kuch nahi hota. Just have to make sure that you are prepared well. You'll get questions from every topic. So my guess is that you'll get a question on differentiation, another on integration, another on quadratics, and so on all the topics. That's the best I can guess. Yes. Any other questions? Any other questions? Any specific questions that you have from past papers or anywhere?
Sir, Assalamu alaikum.
Walaikum assalam. Who's this? जी कौन है? Please go ahead.
सॉरी सर, सॉरी सॉरी सर, मुझे वो बुला रहे थे। सही, आपने इधर बीटा कंसीडर किया है ऑप्ट्यू, यानी ये 90 से बियॉन्ड जा रहा है, तो इसमें आगे आपने वो अल्फ़ा का साइन यहाँ पे लगा दिया है, मतलब ट्रायंगल में।
वो अल्फा से हम वैसे बेसिक एंगल डिनोट करते हैं ना, तो मैंने इसके वहां पे ऐसे अल्फा लिख दिया. As in, you don't necessarily have to write it. Basic, but that's just the basic angle. Basic angle is the acute angle with the x-axis.
ठीक ठीक ठीक.
Alpha is the basic angle that you have there. Beta is this angle, the outer angle, because the question says that it's an obtuse angle. It's between 90 and 180. तो वो 90 और 180 के दरम्यान में है, तो वो second quadrant में होना चाहिए. Please make sure that you have good sleep today. पूरी रात पढ़ने की जरूरत नहीं है. Sleep is very important. Sleep is very important. Otherwise, you end up doing a lot of carelessness. Yes, please go ahead. Those of you who are well prepared and are just wasting your time, I think you should go and sleep. Aisha, Navera, Raja, Ambreen, Vanya, you guys have any problems? Have any questions? Those of you who are here in the class, right, and on this in Zoom meeting right now, any problems? Abdul Rafi, Raja. What should you be scoring to have a safe A grade? 62, 63 minimum. In easier papers, generally it goes up to around 62 for an A grade. In very easy papers, I think I've seen one in which it went up to like 66, but normally it's around 60. So you should be targeting, if you want an A star eventually, then P1 should be 70 plus. If you want an A, then definitely 65 plus at least. That's going to be important. Vijay, can you send a picture of that, a snapshot of that in the WhatsApp group? Range of composite functions. How do you find range of composite functions? For composite functions, range does not have any specific method as such. So if we have a composite function, for a composite function, you need to know the domain of the composite function is going to be the same as the domain of the inner function. Whatever is the domain of the inner function, that will be the domain of the composite function as well. And then using that domain, you can find the range of that function. So for instance, this is an example. You have a function fg, and they want you to find the range of fg, right? Range of the composite function. Now, this is the composite function. Its domain is x less than or equal to -3. That's the domain of the inner function as well. Function g has the same domain as well. This is the expression. This is the domain. You just find the range of this like you do for any other function. It's a quadratic function. Find the range of find its range like you do it for a quadratic function. Sketch a graph. Find the turning point. Look at what part of the graph is valid, which region on that graph is valid, and based on that, write down what the range is going to be. So in this case, for instance, the domain was x less than or equal to -3. This point was to the left side of the turning point. We found the y value of this point that turned out to be 33. And on the graph, this yellow part is valid. That means the range is going to be above 33. Okay. Uh, I have not seen that yet. I've heard that it was a relatively easier paper, June 25, paper 1-3. But I have that. I haven't just opened it because I thought, what's the point? But let me just open it right now. If you have any questions, any specific questions on that, we could have a look at that as well. So those of you who have that paper, uh, if you have any specific question on that, we could discuss that. Although I've heard that it was a relatively easier paper. Okay, let's come to that in a few minutes. If you have any specific question on that, we could have a look at that. Before that, we'll have a look at this example. Let me share that here. Okay, so this is an APGP question. An APGP question, let's have a look at this. Okay, let's try this quickly. The first term of a convergent geometric progression. Convergent geometric progression. What is a convergent geometric progression? A GP converges when the ratio of that GP is between -1 and 1. So the condition that we have for sum to infinity, it's the same condition for convergence of a GP as well. It's the same condition for convergence of a GP as well, okay? Now, they're saying the first term of this GP is 10, okay? A is equal to 10. The sum of the first 4 terms of the progression is P, so S4 is equal to P, and sum of the first 8 terms is Q. It's given that Q over P is equal to 17 over 16. What we need to do is find the 2 possible values of the sum to infinity. Now, what's the formula for sum to infinity? Sum to infinity is given by A over 1 minus R. A is already known, that is 10. We need the ratio. So there will be two possible values of ratio that we would get somehow. And using that, you could find the sum to infinity as well. How would you do that? Sum of the first four terms, that is the formula for that. Sum of a GP is given by a into 1 minus r raised to power n divided by 1 minus r. Just input values in this. A is equal to 10 into 1 minus r raised to power n, which is 4 in this case. Can you guys still hear me? There was some problem here. You guys can still hear me, right? Can you also see my screen? Yes? Okay, good. Thank you. So 10 into 1 minus r raised to power 4 divided by 1 minus r, that should equal p. And for the other one, you have 10 into 1 minus r raised to power 8 divided by 1 minus r, that should equal q. We get these two equations, solve these two equations, find the value for r from this, although we have two equations here. And now we're also given this q over p is equal to 17 over 16. We could perhaps use that now. So we are given that p over q is equal to q over p is 17 over 16. So now we know that p is equal to this and q is equal to this, right? So we could use that. We could say q over p, as given in the question, that should equal 17 over 16. What's q? Q is this expression. So we can write it separately to make things easier to understand. This is q, 10 into 1 minus r raised to power 8 divided by 1 minus r. That divided by p, which is 10 into 1 minus r raised to power 4 divided by 1 minus r, that should equal 17 over 16. Right? Now, when you replace this with the multiplication sign, it ends up being something like this. This over 1 minus r into 1 minus r divided by 10 into 1 minus r raised to power 4, that equals 17 over 16. And now what happens is 1 minus r and 1 minus r, they get cancelled. 10 and 10, they get cancelled. And we're just left with 1 minus r raised to power 8 divided by 1 minus r raised to power 4. That equals 17 over 16. Cross multiply, and that gives you 16 minus 16 r raised to power 8. That equals 17 minus 17 r raised to power 4. Take all terms to one side, and that will give you 16 r raised to power 8 minus 17 r raised to power 4 plus 1 equals 0. And now you can solve it as a disguised quadratic. Okay, just a heads up, light जा सकती है किसी भी time. That's what happens in Lahore. So there's a very strong wind outside. I hope it's just wind and not something serious apart from that, because काफी ज़्यादा जोर से यहाँ पे आवाजें आ रही हैं, and we're very close to India as well. Okay, so as expected, we don't have electricity anymore. Why is my camera still on? And turned off. Okay. Can you still hear me? Can you guys still hear me? Again, I'm on my 4G now. यहाँ पे इतने अच्छे signals नहीं आते, but let's see how it goes. Acha. So we have this disguised quadratic equation. Okay, we have this disguised quadratic equation, and what we can do now is we can use a substitution. We can say let u equals r raised to power 4. Smaller power could use a substitute. You get a quadratic equation from that. That becomes 16u squared minus 17u plus 1 equal to 0. Solve this quadratic, you get some values of u. ये process दिखाना जरूरी होता है. You cannot write down the final answer after this directly. That's not acceptable. You have to make sure that you show working for this. Okay, you have to show working for this. That's necessary. So you show working for this. You find the values of u from this. You can see what they turn out to be. 16u squared minus 16u minus u plus 1 equal to 0. We get two factors from this, 16u minus 1 and u minus 1. U is either equal to 1 over 16 or it's equal to 1. Put that substitution back and you get r squared equals 1 over 16, r squared equals 1, r equals plus minus 1 over 4, or r equals plus minus 1. We're getting four possible values of r. We're getting four possible values of r, right? चार values आ रही हैं. चार values आ रही हैं r की. So we want two possible values of sum to infinity, right? Now, since we're talking about sum to infinity and we're talking about a convergent progression, r has to be between minus 1 and 1. So it cannot be this, right? It cannot be plus minus 1. It has to be between those values. Plus minus 1 or minus 1 is not possible, right? So the only possible values of r that we have there for r equals 1 over 4 and r equals minus 1 over 4. And then you can find the sum to infinity from this. You know that the value for a is 10. You can find the two possible values of sum to infinity. 10 over 1 minus 0.25. That will give you one answer. And 10 over 1 minus 0.25. That will give you another answer. And that's it. That's the solution that you get from this. All right. Yes. Any other questions? Yes, Amna, I'll be doing that inshallah. So the day before the exam, I generally do this. I just do an open session for anyone to ask any questions that they might have. Yes. Any other problems? Any other problems? P15. I'm not sure if the China paper, if they have the same syllabus or not. I'm actually not very sure about that. But we can have a look at the question and see if that is something that is part of our syllabus. You can share that. So let me go down here. We've already talked about this GP question. We're done with that. Okay, now where are you doing those questions? Okay. U was r raised to power 4. Okay, I'm sorry about that. U was r raised to power 4. I just read those messages. So it just changes according to that. It was the time when we were having those winds, I think. 1 over 2 minus 1 over 2, and this becomes 0.5 and 0.5 here. So this is 1 minus 0.5 and 1 minus 0.5. And you can see what you get from that. One possible value that I'm getting is 20 from here, and from the other one, 10 over 1.5. You can see whatever that value is. Maybe I think probably around 6.67. These are the two possible values of sum to infinity that we get. Okay. Abdul Rafi, can you send a better picture of that on WhatsApp? That will be easier. On WhatsApp, it will be easier. Significant figures and decimal places. Rules for that? Seriously? Okay, so I thought you were asking about how do you figure out what's the number of significant figures in a particular number. Okay, so I understand that better now. So the general rule is if you look at any specific paper, open older one, look at the instruction that's given. It says give non-exact numerical answers correct to three significant figures. If you get an exact answer, it's better to leave it as an exact answer. Leave it in exact form. You do not round that off. If you're getting a non-exact answer means if you have something random like this, for example, where's the calculator? Okay, so if you're getting something like this, you do some calculation and you end up getting something of this form. Now this is 63.33333. It's a never-ending decimal. Or we can actually use something else here. 64 divided by 7 minus this. If it's better to write a fraction, but if you get in decimal a value that looks like this, you have a lot of decimal places here, right? 8.476190476. It's not stopping at any point. So on your calculator is showing you the maximum number of decimal places that it can show. In this case, you would round it off to three significant figures in your final answer, not in your working. In your final answer, you're going to round this off to three significant figures. If it's in degrees, then you would write one decimal place. For anything else, you write three significant figures. I hope everything stays fine. बहुत ही ज़्यादा strong wind. It's not raining as well. Okay. dy is less than 0. Okay. Let me open this quickly. Okay, so this is the instruction that's generally given in the exam. You generally just follow this. If a question specifies that you have to give an answer to a certain number of decimal places or to a certain number of significant figures, then you have to make sure that you follow that. Otherwise, this is the general rule. If the question is silent about it, you just follow this instruction. Okay. I've just received it. Okay, I think we talked about this the other day as well. When you have a question like this, where they say, we talked about increasing and decreasing functions here, I think. We saw that question. So it's very similar to this, right? So I'll just use this to explain that. You have equation of a curve that looks like this: 4 plus 5x plus 6x squared minus 3x cubed. It says find the set of values of x for which y decreases as x increases. What does that mean? As you go to the right side, the y value decreases. So the graph is going in the downward direction. If the graph is going in the downward direction, what does that tell you about the gradient? The gradient is negative. Gradient is negative. It's a decreasing function. So this is just another way of saying find the values of x for which it's a decreasing function. When you have a decreasing function, when gradient is negative or the derivative is negative, so find dy by dx, put that less than 0, you get an inequality, solve that inequality, and you get the solution for that. Does that make sense? Is that all right? So when they say y decreases as x increases, that means it's a decreasing function. If they had said y increases as x increases, then it would be going in the upwards direction, and in that case the derivative would be positive. Okay, you would put dy by dx greater than 0 in that case. In this case we put that less than 0. All right. Okay, any other problems? Let me open that. Abdul Hadi, can you please rotate these and then send them? Okay, second, third, fourth pages, they are fine. But the first page, that needs rotation. So I'll just open this as well. Anyone else who has any questions? Okay, I'm going to skip the first one because I can't see that properly. So this equation can be written in this form and hence solve this equation. Okay, so let's have a look at this. The second part, the first part you're done with, and you got this 5 sine squared theta plus 7 sine theta minus 6 equal to 0. Now in the second part, they're saying hence solve. So any questions that you send, please send the original picture as in without any working, so that becomes easier to work on that. So you have cos theta into 7 tan theta minus 5 cos theta equal to 1. And using that, they want you to solve this equation, right? Now compare the two equations. What has changed here? In place of theta, you just have 2x. That's the only thing that has changed there. Theta has been replaced with 2x. So you already have this form. In this form, you replace theta with 2x. Okay, in that form, you replace theta with 2x. So it will look like this. It will become 5 sine squared 2x plus 7 sine of 2x minus 6 equal to 0. That's the equation that you now need to solve. And the interval for x is from 0 to 180. That's the interval that we got for x. That's the equation that we need to solve here. Now, how do we solve this equation? So we need to solve this quadratic equation for x between 0 and 180. What we can do is we can use a substitution here. First of all, to solve this quadratic equation, let's write it like this: 5s squared, and in place of sine, I'm writing s. 5s squared plus 7s minus 6 equals 0. Now, it becomes 5s squared plus 10s minus 3s minus 6 equal to 0. What do we get from this? 5s minus 3 and s plus 2. So s equals 3 over 5 or s equals minus 2. Put that substitution back and we say sine of 2x is therefore equal to 3 over 5 or sine of 2x is equal to minus 2. Now minus 2 is not possible. Sketching of the graphs, we will talk about that. Okay, next we'll talk about that quickly. Sine 2x equals 3 over 5, sine 2x equals minus 2. Now, this is not possible because sine is supposed to be between minus 1 and 1, so we ignore this value. How do we solve this one? We can use a substitution for this. Since the angle is not just x or theta, it's 2 times x. We can use a substitution. We can say let a equals 2x, and that gives us sine of a equals 3 over 5. Now we have to adjust the interval as well. We know that for x, the interval was from 0 to 180 degrees. That was the interval for x. What will be the corresponding interval for a? Input x equal to 0 here. That gives you 0. Input x equal to 180 here. That gives you 360. So x is supposed to be between 0 and 360. Sorry, a is supposed to be between 0 and 360. So now you have to solve this equation for a between 0 and 360. Okay, how do you do that? Find the basic angle. Sine of alpha equals 3 over 5. What's the basic angle that we get from this? It's supposed to be in degrees. So sine inverse of 0.6, that gives us 36.87. That's the basic angle, 36.87. Now look at quadrants. Which quadrants can you be in? Sine is positive. That's first or second quadrant. Now that means A either equals 36.87 or the second possible value of A would be in the second quadrant. So it can either be here or it can be here. In the first quadrant, it's just 36.87. In the second quadrant, it would be 180 minus 36.87. Put that substitution back, you get 2x equals 36.87 or 2x equals this, whatever this is, 143.13. And you find the value of x from this 18.4 from here and 71.6 from here. 71.6 from here. These are the two possible values of x that we get, and these are final solutions. Make sense? Negative range in trigonometric functions and sketch of that graph. Okay, let's talk about this next. We'll come back to the next questions, Abdullah, in a moment. Let's do a couple of others first. Negative range in trigonometry question. So all you have to do is, if you have a negative, some negative values in the interval. For example, if you end up getting something like this while you're solving an equation, let's say at the end you have an interval like this, maybe cos theta equals 1 over 2, you got this, and the interval was from minus 180 to plus 180. Now what does that mean? You find the basic angle like you normally do. The basic angle turns out to be 60 degrees. Now 60 degrees is the basic angle. You draw quadrants like this. You say, okay, cos is positive. Where is cos positive? Cos is positive in the first quadrant. It's positive in the fourth quadrant. Now the interval that's given is from minus 180 to plus 180. Okay, now first of all, let's find the positive angle as we normally do. This is where we start measuring the angle from. This is the first angle. That turns out to be 60 degrees. Then we go further and we get to this next angle. Now that is going beyond 180. So we cannot consider that because our interval is only up to 180. But the interval also has negative values. That's also inside the interval. What do we do? What do we do about negative values? For negative values in the interval, we have to go and see clockwise in the clockwise direction if there's any other angle that you get in the clockwise direction. So if you go clockwise from here, this is what we get in the clockwise direction. This is the first angle that we're getting. This is negative 60. So this is another possible solution that you have. You can go even further, but that goes outside the interval, so you cannot consider that. That will go beyond minus 180. So all you have to do is, whenever you have a negative value inside the interval, whenever the interval is going in the negative direction, you see in the clockwise direction if there's anything that you're getting inside the interval in that direction or not. If yes, then you would also have to consider that. So you just check in the clockwise direction. How do you sketch that weird graph that you have here? For any graph, for whatever graph that you have, for sketching, just use the table function on your calculator. Do not think about transformations. That's very confusing. Do not think about transformations. Just input the function in the table function on your calculator. So whatever that is. For example, if your function is 3 cos of x minus pi, if you have to sketch this graph and you have plus 2 outside, now most likely the form in which you've written this here, you're saying this is the graph for, okay, this is g of x. Okay, that's okay. So this is the graph that you've got. Now, if they have already given you the cos x graph there that you have to use for drawing this graph, then you can think of transformations that, okay, this is going pi units to the right, and then its baseline is moving up by 2 units, and its amplitude is multiplying by 3. You could think of it like that, but the easiest way of sketching graphs, any trigonometric graphs, is if the interval is from 0 to 2 pi here, you would say, let's just input this on your calculator. Go to the table function. First of all, make sure your calculator is in the correct mode. Angle unit should be radian. Now go to menu, go to the table function, input that function as it is in your calculator, 3 cos of x minus pi, and then plus 2 outside. Skip g of x because we only have one function to plot here. Start from 0, end at 2 pi. And then the interval that you have, you divide that by 8 generally to have a sufficient number of values. Dividing by 4 is also going to be enough if you know your graph shapes well. So if you remember that cos graph is going to look something like this, it's going to be either this or it's going to be that graph inverted like this. It's going to be one of these two forms, one of these two shapes, right? In that case, you can get away with just dividing that by 4. The total interval, this is 2 pi. You can just divide that by 4, and that gives you pi over 2. So you can take an interval of pi over 2. If you understand the shape from that, that's going to be sufficient. If not, you can divide it further, make pi divided by pi divided by 8 instead. Dividing by 8 would give you pi over 4 as the step. So either take pi over 2 as the step or pi over 4 as the step. I'll just take pi over 2 here because we know the shape of cos function, what it's going to look like. We've got these values. Using these values, we'll just plot this function. We'll do something like this. We would say these are our x and y axes. We've got y-axis here. We've got x-axis here. On the x-axis, we have to go from 0 to 2 pi. Let's break it down in the middle. That's pi. Break it down further in the middle. That's pi over 2. Multiply this by 3. And that gives you 3 pi over 2 here. On the y-axis, the minimum value that you see here is 1. Okay, why is it not moving up or down? There's some problem with this. Okay. Minus 1 is the minimum value and 5 is the maximum value. So take your scale according to that. Minus 1 is the minimum value. So since I've drawn it like this, I could say this is 2, this is 4, this is 6, and this is minus 2. Let's plot those values. At 0, we've got minus 1. That will be here. At pi over 2, we have 2. And then the next value is 5. And and then the next value is 2, and the next value is minus 1 again. These are the points that you have. Just join them using a cause function. Now, if you remember the cause graph, then you would draw it correctly after this. You know the shape is going to be either this or the opposite of that, like this. Which one is it? It's the second one. It's going to look something like this. You would draw that shape here. Let's say it goes like this, then it changes direction and it goes like this, then it goes like this, and then changes direction and goes like this. That's what the graph is going to look like. If you do not remember the shape well, then you would divide the interval further. Instead of taking pi over 2 as the step, you would change it to pi over 4 so that you have more values in the table. So you can plot them as well. So you might get another value here, somewhere, another value here. And that might help you understand the shape of the graph better if you don't remember the cause graph. Otherwise, if you remember the graph shape well, that's actually a good idea to remember the shapes. Then you can just take a few points and then using them, you can draw that graph, and that becomes pretty straightforward. You do not have to think about it that much. Yes, I'll be doing a stream like this for paper 3 as well, inshallah, the day before the exam. This is what I normally do. I just do an open stream in which you guys can come up with any questions that you have. So, yeah. Yes. Any other problems? Any other problems? Let me go back to that file now. So this is how we sketch graphs. Let's get back to this. So next we've got this points A and B on the curve have these x coordinates. Okay, we need the previous parts for this. On some curve, we've got these 2 points. They have these x coordinates. Okay, so we don't have the first 2 parts. I think it's not a continuation of this question, I think. Or is it? It's not. These look like different questions totally. Yes?
नहीं नहीं सर, ये कंटिन्यूशन नहीं है। मैं आपको इसी का वो पार्ट ए भेज देता हूँ जिसमें उन्होंने कर्व्स दिए हैं।
Okay. Okay, this is actually a very good question. I think we did this recently. This was, does anyone remember which paper this was from? Was it March that we did? March 25? Paper 1, 2 questions, 11B and 11C. I think it's the same. It's the same question that you were asking about as well. Let me go to that paper quickly. March 25. This is P1. March 2025. This paper. And we have question number 11 from this. Oh no, that's a different question. Okay, we'll do that first, and then we'll come to this. Do you know which paper this is from? Or in fact, we have this here, so we'll just do it from here. It says it's given that f dash of x of 0, that means derivative. Okay, let's think about it. Let's think about it. It says it's given that f dash of x, the derivative of a function, is equal to 0. This equation can be expressed in this form. Determine, making your reasoning clear, whether f is an increasing function, a decreasing function, or neither. How do you do that here? Now, the derivative is given like this, but it's not just the derivative. We cannot be sure that f dash of x is equal to 125x squared minus 128x plus 192. We cannot be sure about that. Why can we not be sure about that? Because it's the equation derivative of f equals 0. It is possible that the actual derivative was some multiple of this. So maybe it might have been this minus and then this and then this. It could also have been this. And when we equate that to 0, we could convert it to this form: 125x squared minus 128x plus 192 equal to 0. So it could be any of them. It could be like this. It could be like this. Any of these are possible. Okay? Any of these are possible. That's one thing that you need to understand. The derivative could be this expression, or it could be with a negative sign like this as well. Now, how do you figure out if this derivative is positive or negative, or it could be any of them? How do you figure that out? That's the question. Let's think of this expression. 125x squared minus 128x plus 192 equal to 0. Now, this is the derivative. It's a quadratic expression. The derivative is a quadratic expression. Now, it could be like this, depending on if the actual x square coefficient was positive, or it could be like this. It's one of these two shapes. Let me actually look at the previous part of this quickly, because that we might have solved this equation here, because how many marks is this? There's 3 marks. So I think some of this work we might have done in the previous part. You're saying this is November 24, paper 1. Which variant is this? 1-3. 1-2 or 1-3. Okay. Let me check that quickly. No, it's not 1-3. Okay, it's this one. So what have we done in the previous part? So this is the complete question. So we have this function f with domain x greater than 0, and it's such that the derivative is given by this. Okay, so this is the actual derivative. Or is it that same question? Yes, it is that same question. Okay, so this is the information that we actually have about this. Okay, a function f with this domain is such that the derivative is equal to this. It's given that the curve with this equation passes through the point 1, 0. Find the equation of the normal to the curve. So you've done that in the first part. And then in the second part, you found the equation of that function as well. So that's also done. And now in the third part, they're asking for this. What I'll do is I'll just copy this here, the question. We need to determine whether f is an increasing function, decreasing function, or neither of them. Now, how do you do that? The actual derivative looks like this. The actual derivative, they've given that to us. That is this function actually. It's 8 into 2x minus 3 whole raised to the power 1 over 3 minus 10x raised to the power 2 over 3. That's the actual derivative. They're saying when we put this equal to 0, we can rearrange this to get an expression like an equation that they've given here, that when we equate it to 0, this is what we end up getting: 125x squared minus 128x plus 192 equals 0. Now, this is a quadratic equation. Can we solve this equation? Let's figure that out. The shape of this quadratic function is going to look like this. In this form, in the current form, it's going to look like this. There are 3 possibilities. It could either intersect the x-axis at 2 points. In that case, some of this will be positive and some of it will be negative. So we could say the derivative, some part of it is positive, some part is negative. That means the gradient of the function is positive in some part, it's negative in another part. In that case, it would be neither. Or it could be above the x-axis, all of it, or it could be just touching the x-axis. Let's figure that out. Let's figure out which one of those cases it is. Can we solve this equation somehow? In this case, we've got this function. Can and we find any values of x from this. Now you can either put these values in the quadratic formula, that's one idea, minus into minus 128 plus minus square root of minus 128 whole squared minus 4 into 125 into 192 square root of that divided by 2 times 125, and then you figure out if you get any solutions from this or not. Or to make this process a bit more efficient, you could just find b square minus 4ac, and that would be to see if this equation has any solutions or not. Right? So we just want to figure out if this equation has any solutions or not, and if they are, what happens in that case. So let's actually try to do that. In this case, what do we get inside the square root? We get 128 squared minus 4 into 125 into 192. Okay, so we end up getting a negative value inside the square root, and that's telling us that there's no solution for this. Now, what does that mean? That means that the derivative is not equal to 0 at any point. The derivative is not equal to 0 at any single point, but that's possible. X is defined for all real values apparently here. Now, x is greater than 0, so any value, for any value greater than 0, this derivative is never equal to 0. F dash of x is never equal to 0. Now, what does that mean? It's a quadratic function. If it's never equal to 0, now again, depending on the actual function, it might have been that while when they simplified it, they had a negative number here like this, 125x squared plus 128x minus 192 equals 0. As I explained earlier, it could be this form, and which they converted to this form. Any of these could be possible. So since we are getting no solutions, there are two possible cases that we get from this. Either the derivative looks like this, or the derivative looks like this. It's one of these two possibilities. Either it's always positive, that means it's an increasing function, or it's always negative. In that case, it's a decreasing function. Now, how do we know which one it is? Whether it's always positive or always negative? This at least tells us that it's going to be one of these two. It can't be neither. Neither is when some part of the derivative is below the x-axis and some is below the x, some is above the x-axis. In that case, some of it is increasing, some of it is decreasing, and you would say it's neither. But what this no solution proves is it's either always positive or always negative. Now, which one of those two is? We've got the derivative for that. We've got the original function for that. What we can do is we can say in that original derivative that we've got, the actual derivative, that was this, f dash of x equals 8 into 2x minus 3 whole raised to power 1 over 3 minus 10x raised to power 2 over 3 equal to 0. We know x is greater than 0. Input any value of x in this. Input any value of x in this and see whether you get a positive derivative from that or a negative derivative from that. Input x equals 1, for instance, any value in the domain, you can input that here and see what the derivative value turns out to be from that. If I input 1 here, I would get 8 into minus 1 power 1 over 3 minus 10 into 1 power 2 over 3. And that simplifies to minus 8 minus 10, and that's minus 18. That means there's at least one value at which the derivative is negative. So we were saying it's either always positive. It can't be always positive because we're getting at least one negative answer here. We're getting at least one negative answer here. This proved that it's either always positive or always negative. It's one of these two cases, either always positive or always negative. It has to be exactly one of these. If there's at least one value that is negative, that proves that it can't be this, it has to be this, it's always negative. Generally, you do not input one value to check if it's always positive or negative. But in this case, we have eliminated the possibility of it being neither positive or negative, or neither increasing or decreasing. For that reason, we could just check one value. If one value is negative, that proves that this is always negative, because it had to be one of these two cases, and that shows that this is a decreasing function for that reason. Now, this is one idea. The other idea could be to look at the function. You need to know the graphs of functions. In this case, you see the function that you got, was it a cubic function? Okay, it wasn't. So we can't do that. This is how you would prove it. This is how you would prove it. By inputting one value, you would check that it turns out to be negative. Why x equals -1? Okay, I'm sorry. I'm really sorry about that. That's a mistake. That's a mistake. I input that wrong there. It's 8 minus 10. That's -2. This is negative. So that was supposed to be a positive value. I don't know why I put negative there. Okay, so with that as well, we end up getting a negative value here as well. So the conclusion remains the same in this case. That was 1 here, not -1. Thank you for that correction. So we still get a negative answer. So for any value of x, that means we would always get a negative answer. So it's always decreasing, and that's your solution. Is that okay? This is a one-off that you will find in past papers. This is November 2024. Which paper? Paper 1-2. This was quite tricky. Proving this part. Is that all right? No problems? Okay, let's move on. Let's look at the next one now. Let's look at another one. So you were saying from March 2025. Okay, let's have a look at one question from there. March 25. That was this question. March 25. Let me look at that again. March 25. Paper 1-2, question 11, B and C. Walaikum assalam. 11, B and C. Okay, B and C parts of this question. Okay, so I'm going to just show you the first part, and then we'll do the other two parts then. Functions f and g are defined for all real values of x by this, where c and k are constants. It's given that g inverse of 3k plus 1 is equal to c. Show that g f of x is equal to this. Okay, so you just find g f of x and see what that turns out to be first. So inside the function g, you input f, and that gives you 2 into 4x squared minus c plus k. Okay, I'm just giving a minute. My son is calling. I just need to respond to him quickly. Light bhi nahi hai yahan pe. I think we should all go outside and relax now. Such a pleasant weather outside. काफी गर्मी हो गई थी और एकदम काफी अच्छा मौसम हो रहा है. Functions f and g, they are defined by all real values of x. And we had f and g functions given. और हमने क्या करना था first part में? We had to show that gf of x is equal to this. Okay, so what I did here was I found gf of x and it turned out to be this. And now we also had c here. We had to get rid of that c because in the form that they want, we do not have any c. So they gave us another piece of information, and that was this. If g inverse of 3k plus 1 is equal to c, if I take g inverse to the other side, that becomes g of c. G of c equals 3k plus 1. And then g of c simplifies to 2c plus k. And that gives us c in terms of k. And using that, we can eliminate c from here. Simplify that and we get that form. Okay? All right. Now, the second part says, I'll just copy that here. Skip 1 second. Okay, so this is the second part. It says the curve with this equation is transformed to the curve with the equation y equals h of x by the following sequence of transformations. Now, what is the sequence? Translation of 2, 3, and stretch in the y direction. That means it's a vertical stretch, scale factor k, and reflection in the x-axis. So there are three things that are happening to get to that final function, which is h of x. Okay, we have these three things happening. Find an expression for h of x in terms of x and k. How do we do this? This is the original function, y equals 8x squared minus k minus 1. First of all, we do a translation of 2, 3. What does that mean? If the original function was f of x, where does that go? 2 units right. That means x minus 2. 3 units up. That means plus 3 outside. So inside the function, what you would do would be you would replace x with minus 2. And then outside, you would have a plus 3 with the whole function. These are two things that you would have to do. Okay? Let's do that. Let's apply that first translation. And that would become, in place of x, you write x minus 2. So it becomes 8 into x minus 2 whole squared minus k minus 1. And then with this whole function, you add 3. So that simplifies to 8 into x minus 2 whole squared minus k plus 2 initially. That's the first thing that happens. Okay? And now, once you've done this, the next thing that happens is you have a stretch in the y direction. That's a vertical stretch by scale factor k. What does that mean? The whole function that is going to be multiplied by k, because if you have a function f of x, when you do a stretch by a scale factor of k, in the y direction, that means k times f of x. So we multiply this whole thing by k like this. That's the second thing that's the next thing that happens. Okay, this is the next thing that happens. We multiply the whole thing by k, so it becomes k times 8 into x minus 2 whole squared minus k plus 2. Okay, that's what happens when you do the stretch. What next? Now we have to do a reflection in the x-axis. So x-axis is the line of reflection. If x-axis is the line of reflection, do we call that a horizontal reflection or a vertical reflection? That's the vertical reflection. The points above the x-axis, they move down they move below the x-axis. The point below the x-axis, they move up the x-axis. That's a vertical reflection. In vertical reflection, what we do is we multiply the whole function by minus. So we have a minus sign multiplied outside as well. So this is what h of x is going to be like. You can simplify this if you want. The final form will become minus k into 8. That becomes minus 8k into x minus 2 whole squared minus k into minus k. That's plus k squared 2 into minus k, that's minus 2k. That's the result that you get. This is the final answer. It's not that complicated. The only complication is that they have this in terms of k here. They have the scale factor in terms of k. So rather than using numbers, they've used letters here. That's what makes it slightly confusing for some people. But otherwise, in terms of concepts, it really is not that complicated, this part at least. Now it says the range of h, that is given by h of x less than or equal to 15. Find the values of c and k. How do we do this now? Range of h, this is the function h. It's a quadratic function, right? X squared. So we have power 2 for x. It's going to be a quadratic function. Do we know anything about k? Do we know anything about k? Is that a positive number or a negative number? Okay, so it's k is a positive number. Okay, k is a positive number. If k is a positive number, what that means is the coefficient of x squared that we would have here minus 8k, that is going to be a negative number. So what is the shape of this quadratic function going to look like? It's going to be an n-shaped curve. This is the shape of h of x. This is what h of x would look like, right? Now they're saying the range of this function is h of x less than or equal to 15. That means y less than or equal to 15. That's the range of this function, y less than or equal to 15. So what does that tell you about the turning point of this function? The turning point of this function, this turning point, that is supposed to have a y coordinate of 15, right? Then the range would become 15. Range means y values, its maximum value is 15. That's what they're telling us. This should be 15. So the y coordinate here at this point, at the turning point, that should be equal to 15. That's what they say. What's the y coordinate that we are getting? This is the function h of x. H of x is minus 8k into x minus 2 whole squared plus k squared minus 2k. This is a completed square form, right? In the completed square form, the number that is outside here, that represents the y coordinate of the turning point. It represents the y coordinate of the turning point. So this is the y coordinate of the turning point. We can say that should equal 15. So we get an equation from this. K squared minus 2k, that equals 15, right? The turning point coordinates, according to this equation, what would they be? Put this number equal to 0, x minus 2 equal to 0, that gives the x equals 2. So the x coordinate is 2. What about the y coordinate? The expression that is outside the brackets, that's k squared minus 2k. That's the turning point. They said that it should have been 15, so we equate these two things. Solve this equation, you get the value of k from this. You can see what that is. You can factorize this. You have to make sure that you show this working. You cannot write down the answers directly. That's not acceptable. You can either factorize or put values in the quadratic formula and then write down the answers after that. It becomes minus 5k plus 3k minus 15 equal to 0. And then we have k minus 5 and k plus 3. These are the two factors that we get. K either equals 5 or k equals minus 3. This is not possible because the question said k is supposed to be positive. So the value of k that we're getting is 5. And now we need to find the corresponding value for c. How do you find c? There was no c in this function. What do we know about c? Okay, so we showed in the first part that c is equal to 2k plus 1 over 2. Just input in that now. It was 2k plus 1 over 2. Input values in that, and that will become 2 into 5 plus 1 over 2, and that's 5.5. The value of c turns out to be 5.5, and that's your final answer. All right. Makes sense? Any problems with this? In A levels, they don't give a lot of error carried forward. It's very rare. You get method marks, yes, you get method marks, but the answer marks, they're very rare. It's very rare that they give you answer marks as well.
सर आपने इसके अंदर जो y को 15 सपोज किया, आपने मैक्सिमम वैल्यू 15 ली है y एक्सिस पे, तो ये आपने सपोज किया है या ये क्वेश्चन में इस तरह से है, क्योंकि वो तो
उसने
उसमें।
बताया हुआ है ना कि h of x is less than or equal to 15। फंक्शन की वैल्यू क्या होती है, उसकी y वैल्यू होती है। उसने कहा y is less than or equal to 15, तो मैक्सिमम वैल्यू क्या होगी, उसकी 15 होगी।
सर वो कोई और वे y मतलब वैल्यू भी तो हो सकती है, मतलब वो मैक्सिमम ना हो, पॉइंट ही वो वाला मैक्सिमम ना हो जिसपे वो 15 है।
जब वो फंक्शन क्वाड्रेटिक फंक्शन की मैक्सिमम वैल्यू कहाँ पर आती है, इसी टर्निंग पॉइंट पर आती है ना। तो रेंज इसकी क्या होगी, उस टर्निंग पॉइंट पे जो भी y वैल्यू है उसके नीचे वाला पार्ट। तो जब वो लेस देन और इक्वल टू 15 है, तो इस इनइक्वालिटी से क्या पता चल रहा है आपको, इफ समथिंग इज लेस देन और इक्वल टू 15, the maximum value of this can be 15, so the y coordinate there has to be 15।
ठीक 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 सर, समझ गया।
Should it be plus 2 in the bracket, plus 2 in the bracket in the previous part? uh, y plus 2 horizontal में उल्टा होता है ना, in the vector it says 2 units to the right. In function form, when you write that for horizontal transformations, it's the opposite. In the function form, minus 2 means you're going 2 units right. Okay, Musa, does that make sense? That's the rule that we have for horizontal transformations. In horizontal transformations, it works the other way around, right? Whenever you have, whenever you go right in the function transformations, you have minus, and when you go left in function transformation and horizontal transformations, that means plus. Now there's a logic behind it, but this is the end result that we get from this. In horizontal transformations inside the function, plus b means you're going left, minus means you're going right. In horizontal transformations, that's the rule that we've got. In vertical, plus means up, minus means down. In the function form, in horizontal transformations, plus means you're going left, minus means you're going right. You're going right. If k is stretched in the x-axis, okay. So first of all, that terminology that's not the correct way of describing a stretch. Stretch in x-axis does not mean anything. Please don't write this in your exam. Stretch in x-axis, that's not a correct description. You either say it's stretched along x-axis, or you just say horizontal stretch. You don't use the word in there. Don't use that preposition for stretch. We use that for reflection. Reflection in x-axis would mean reflection with line of reflection as x-axis. But for stretch, we can't use that. We can't have in as the preposition there. That's not correct. Okay. So you're saying if it's a stretch along x-axis. Okay. So if it was a stretch along x-axis with scale factor k, what would happen in that case? In that case, we would just multiply x with the scale factor. Now, what will be the scale factor? And not just the scale factor, reciprocal of scale factor. So we're saying if it was a horizontal stretch with scale factor scale factor k, what would happen in that case? If the original function was f of x, the transformed function would be x divided by k. So in the function notation, you have reciprocal of that. It will be x divided by k or x multiplied by 1 over k. So here, in that case, you would say, if you were applying that stretch to this expression, that would become 8 times x over k minus 2 whole squared minus k plus 2. That's what you would do in that case. Does that make sense? If it was a horizontal stretch with scale factor k, you have reciprocal of k multiplied with x. That's x into 1 over k or x divided by k. And then the rest of it stays like that. In horizontal transformation, you just apply that operation on x. In vertical, you apply that operation on the whole expression, on the whole equation. Okay. Neither. I'll have to find that example. I don't have that right now. Maybe you can share the question number, the paper number, the question number where I can find that example. I can't recall that from the top of my head right now. Or maybe, yeah. So I think I have one example in that, which I can just change a little. That would be here in functions. No, differentiation. Okay, so if you look at this example, so if you had a function 1 over 6 into 2x minus 3 whole cube minus 6x. Let's say you had a function like this, sorry, minus 4x. So you have this function, and what you want to prove is, you want to figure out is whether this function is always positive, is always increasing, or it's increasing or decreasing or neither. Let's say you had to do that for this function. So we've got this function. We need to figure out if this function is increasing, or decreasing, or none of them for this function. How do you do that? You find the derivative. That's the first thing you do. Find dy over dx. Let's see what that turns out to be. Multiply by the power, so it becomes 3 over 6. That's 1 over 2 into 2x minus 3 whole squared times the derivative of the part that is inside. That's 2. Minus derivative of 4x, which is minus 4. Simplify this and you get 2x minus 3 whole squared minus 4. And now you need to prove whether this function is always increasing or decreasing or neither. How can we do this? Now, in this case, we can say this part is always positive. However, we've got this minus 4 here. For this question now, you cannot say that this is always positive. What's the minimum value of this function? It's a quadratic expression, right? We're talking about the derivative. This derivative, it's a quadratic expression. If I were to sketch this quadratic expression, what would it look like? It will be a U-shaped curve like this. What will be the minimum value of this curve? What's the turning point here? It's 3 over 2 and 4. That's the third, and minus 4. That's the minimum point of this function, right? Put this part equal to 0. 2x minus 3 equal to 0. That gives you the x coordinate of the turning point. 3 over 2. And the y coordinate is the number that's outside. That's negative 4. So the minimum value of this expression is minus 4. Now, what does that mean? This tells us that the minimum value of b square minus 4ac is what? Minus 4. Now, if the minimum value is minus 4, that means dy over dx, this derivative, it could be both positive and negative, right? Because greater than or equal to minus 4, that means you could have minus 3, you could have minus 2, you could have minus 1. You could also have positive values. So you can have negative values, you can have positive values. And for some values of x, the derivative is positive. For other values of x, the derivative is negative. So what do we say then? The function f of x is neither increasing nor decreasing. It's neither increasing nor decreasing, right? Because it's not always positive or negative. In this case, you could also just input some value. For neither case, that works. For one value, you can show that it is positive. For another value, you can show it's negative. And that will prove that it's neither increasing nor decreasing. That would work in this case. But when you have to prove that something is always positive or always negative, for that, generally, you don't just input values. You have to prove that in general. Okay, I hope that makes sense. Let's look at another one. Okay, that's another question that you've sent. Let me look at that. Okay, after this, I'll look at March 25, question 5. Okay. Uh, this and then the second part of this. Okay, so it's the second part that you're asking about, right? And this is the second part. Let me copy that here somewhere. Okay, let's look at this. Can't have this in front for too long. Okay, the function f is defined by f of x equals this for all real values of x. By completing the square, find the range of f. Now, the first part is straightforward. How do you complete the square for this? Minus x squared plus 6x plus 10. You can take minus common outside. That leaves you with x squared minus 6x inside, and you have plus 10 outside as it is. Add 3 squared here, minus 3 squared. These three terms give you a perfect square, and you have minus into x minus 3 whole squared minus 9 outside plus 10 outside. And that gives you minus into x minus 3 whole squared plus 9 plus 10. That will be plus 19. That's the function that you would get from, that's the completed square form that you would get from this. Right? That's the completed square form. Now, it's an n-shaped function, so it will have a maximum value. The function is going to look like this. It has a maximum value. What's that maximum point? X coordinate is 3, and the y coordinate is 19. So what's the range of this function then? Less than or equal to 19. So you say the range of this function therefore is y less than or equal to 19. That's the range of the function because the domain is all real values. Okay, so now assuming that we're done with this, the next part says the function g is defined by g of x equal to 4x plus k, where x belongs to any real, x is any real number. It's given that the graph of y equals g inverse of f meets the graph of y equals g of x at a single point P. Determine the coordinates of P. So we've got two graphs that meet at a single point. Now, first of all, let's find those two functions that they're talking about. One is g of x. G of x is given here, 4x plus k. Okay, let me just write down those two functions here. We got one function f of x. We have completed the square for that. Let's just use that form, minus into x minus 3 whole squared plus 19. And the other function is g of x, and that's 4x plus k. Both of these functions are defined for all real values of x. Okay, now first of all, let's find g inverse of f. For that, we need the g inverse function first. What's g inverse going to be? Y equals 4x plus k. Make x the subject, and that will give you y minus k over 4. And the g inverse x function turns out to be x minus k over 4. That's the g inverse function. Now, once we have got that, we can use that to find g inverse of f. Let's do that. Inside g inverse, we have to input f, so it becomes g inverse of minus into x minus 3 whole square plus 19. So that's minus into x minus 3 whole square plus 19 in place of x here, minus k divided by 4. This is the function g inverse of f of x. Okay, now this is one expression, this is one function, g inverse of f, that they're talking about. And the other function is g of x. This is the other function that they're talking about. And they are saying that they meet at a single point P. The line meets this. This is a quadratic function. The one here, this is a quadratic function. This is a straight line. A quadratic function meets a straight line at a single point. What does that tell us? That tells us that the line is a tangent to the curve, right? The line is a tangent to the curve, and b square minus 4ac is therefore going to be equal to 0 in this case. Make sense? B square minus 4ac should be equal to 0. So when we equate those two functions, we just put b square minus 4ac equal to 0 in that to find the value for k in that, first of all. So we've got this equation, g inverse of f of x, that should equal 4x, that should equal g of x. That's the equation, right? We're talking about these two graphs meeting. That means when we solve them simultaneously, the points of intersection that we have, the solution that we get from that, they represent the points of intersection. So we've got one function here on the left side. It looks like you would have to expand it. So let's expand it first, or let's just use the original form then. I can just replace this thing with 10 plus 6x minus x squared to just simplify things. 10 plus 6x minus x squared. I'm using the original form now because we have to simplify that anyway. So I'm just replacing this whole thing with the expanded form, okay? Then we have minus k, that divided by 4, that is equal to 4x plus k. Multiply 4 on the other side, and that gives you 10 plus 6x minus x squared minus k equal to 4 into 4x, that's 16x, plus 4 into k, that's 4 times k. Take everything to one side and see what that gives you. I can take everything to the right so that I get a positive coefficient of x squared as well. That simplifies things, x squared. And then if I take 6x to the right, that will become plus 10x. And then 4k plus k from this side, that will become 5k. And then 10 to the other side, that becomes minus 10. That equals 0. That's the quadratic equation that we're getting. Can you spot any careless errors anywhere? Is this all right? Looks okay, I think. We had 6 terms there, x squared, and then we had 10x from there. That's 3 terms handled, and then 5k minus 10. So that looks okay. Now we just put b square minus 4ac equal to 0. In place of a, we've got 1. In place of a, we've got 1. In place of b, we've got 10. And in place of c, we've got 5k minus 10. So what we have to do is put b square minus 4ac equal to 0. B is 10, so that's 10 squared minus 4 into 1 into C, which is 5k minus 10, this should equal 0. Simplify this, you get the solution from this. 100 minus 20k plus 40 equals 0. 20k equals 40. The value of k turns out to be 7. Once you've got the value for k, you input that value for k back here. You'll get the x coordinate of the point P. And then input that in the function, you get the corresponding y coordinate. Is that okay? You can do it after this? Is it doable after this? So you got the value for k. Input that in that function now. X squared plus 10x plus 5 times 7 minus 10 equal to 0. And that gives you x squared plus 10x plus 25 equal to 0. And that gives you x plus 5 whole squared equal to 0. X equals minus 5. Put that value back in the function. You can input that here, or you can input that here. You get the corresponding y value. Sorry, not there. And the g inverse of f function, this function, I can just input that in the linear function, which is 4x plus k. Y equals 4x plus k, that's 7. So it becomes 4 into minus 5 plus 7, and that gives us minus 13. So the point P that we were looking for, that's minus 5 and minus 13. That's your final answer. Is that okay? Any problems with this? Okay, May, June 20, May, June 20, no, May, June 2013 or 25. Okay. Oh, all right. So that's the most recent paper. I was just surprised with what you're talking about. May, June 2025. Okay, all right. Let me find that. Let me find that here. Okay, I think somebody shared that paper, Abhi. Let me find that in the other group. So, what? Okay. May, June 25, paper 1-3, question number 10. I hope I don't have a copyright strike because of that. Let's just copy this here. So I'll share this part here first. Okay, and then the other one. Okay, so it's the third part that you're confused about, part C. Okay. Let me copy that here. This is May, June 2025, paper 1, variant 3, the most recent paper that we had in another country, another zone. Let's look at this. Okay, so in the first part, you're just supposed to find the coordinates of the two stationary points, and then you have to find second derivative and hence determine the nature of the stationary point. So you're done with that. Part C is what you're talking about. Let's try this. So it says the curve C is transformed to curve C1 or okay, whatever, using a translation of -3, 7 and followed by a reflection in the x-axis. State the coordinates to the maximum point of that transformed curve. Okay. Uh, can you tell me the solutions from the previous part? The stationary points are 4, 6. Okay. 4, 6, and 1 minus 6. And which of them is maximum? Which is maximum? Because they're talking about maximum point, right? Or yeah, tell both maximum and minimum because we have a reflection here as well. So that might change as well because of that. Which one is maximum? Which one is minimum? Okay, so in this function, 4, 6 you're saying is minimum and 1 minus 6 is a maximum. Okay, all right. So these are the two stationary points that we've got. Now, what happens here? You're doing a translation of -3, 7 followed by a reflection of the x-axis. Let's consider both of those points. Now, keep in mind what that point was originally. So minimum point was 4, 6 and the maximum point was 1 and -6. These are the minimum and maximum points. Now, what's the transformation that you're doing? First of all, you're saying you have to do a translation of -3, 7. -3, 7 means you go 3 units left and you go 7 units up. So where does this point go first after that translation? X-axis, you from the x-axis, you on the x-coordinate, you subtract 3. So it goes 3 units to the left and it becomes 1. And with the y-coordinate, you have +7. So 6 plus 7, that becomes 13. And what about the other point? This goes to 1 minus 3 minus 2 minus 6 plus 7, that's 1. And then you have a reflection in x-axis. What happens when you have a reflection in x-axis? That's a vertical reflection. That's a vertical reflection. So point that was above the line, that goes below the line. The point that was below the line, that goes above the line. Y coordinate gets multiplied by -1. So this would become 1 minus 13. And this would become -2 minus 1. Now, which point are we talking about? Which point are we talking about? Since we have a reflection in x-axis, think about it. If there was a maximum point, which was like this originally, after reflection in x-axis, that becomes this. That becomes a minimum point. Because of that reflection, the maximum and minimum points are actually going to interchange. The maximum minimum points, they are going to interchange. In the original function, what was the minimum point? That becomes the maximum point here. So the maximum point of this transformed function, that would actually be 1 and -13 and not the other one. This will be the maximum point. So the minimum point of the original function, because of this reflection, that becomes the maximum point. On Cracky level, do they say something else? They might not have considered this. They might have just said that whatever was the original maximum, they would have said that that's the maximum here as well, but that's wrong. That would not be correct. Yeah, that would not be correct. That would be wrong then. Okay. Yeah, so it should be 1 and minus 13. Because of this reflection in x-axis, the minimum becomes maximum, the maximum becomes minimum. So it will be interchanged like this. The correct maximum would be 1 minus 13. Okay, then you can do the next part after that. Okay. Any other problems? Any other problems? March 25, question number 5. March 25, question number 5. Okay, so can somebody please share this in the group as well? So, because a lot of people have that going on, uh, as in they're looking at this solution from crack A level. It's going around, it's doing the rounds in a lot of different groups. So maybe you can share this in our group that this solution is wrong. Okay, now can you please explain March 25, question number 5? Okay. March 25, question number 5, and we finally have electricity here. Okay, I'm sorry, my uh, internet had some issues. Okay, I'm sorry, my internet had some issues. I think I'm back now. Can you confirm if you can hear me again? Can somebody confirm if you can hear me again? Okay, thank you. All right, so in this question, basically, you have to find the sum of all the terms that lie between 150 and 400. Between 150 and 400. So you have to first find out which are those terms that we're talking about. What are those terms that we're talking about? How do you find those terms? The first term has to be greater than 150. So what you can do first is you can find the first term using the nth term formula. You can say this is the nth term formula, a plus n minus 1 times d. In this formula, you can say the nth term, using this formula, the nth term turns out to be the 6n minus 1. You are looking for the first term that is greater than 150. And that gives you n greater than 25.17. So that means the first term that you would have that satisfies that condition, that it's greater than 150, that would be when n is equal to 26. That's the first term that you would have, n equal to 26. You could also, if you want, you could just think about you could just make an equation for this, 6n minus 1 equal to 150. That would give you n equal to 25.17. And then you have to think of this, that they're saying the term has to be between 150 and 400. A value of an n value of 25.17 gives us exactly 150. So the next value, 26, that is going to give you a value inside this interval. So the smallest value of n that you have, that gives you a value between 150 and 400, that is 26. Similarly, you find the last term within that interval. How would you do that? You would say that nth term that we found, let's put that less than 400. And that gives us n less than 66.8. So corresponding to 66.8, we get 400. We want something less than 400. So that means that the value for n that we use here is going to be 66. We want to find the sum of all the terms from n equal to 26 to n equal 66. From 26th term to the 66th term, that is what we are looking for. How do you find the sum of all of these terms? That's a general concept that we learn in ABGB. To find sum of a certain number of terms in the middle, in this case from 26 to 66 term, you can say, let's find the sum of all 66 terms first, subtract from that the sum of the first 25 terms, and that will give you the terms that you want. So S66 minus S25, and put them in the formula and you get the result from that. Does that make sense? Is that okay? Yes. All right. Any other problems, anyone? Any other problems? Any other questions? Or should we just call it a day then? It's 10:40 now. Maybe you can do some revision now and sleep and have a good sleep today. That's important for your exam. Otherwise, a lot of careless errors happen in these exams because of lack of sleep. So make sure that you have enough of that today. Don't get tired before the exam tomorrow, please. Don't stay up all the way from Fajr until the exam. That's not a good idea. Have a short nap in the middle as well so that you're fresh for the exam. Okay, so those of you who think you are well prepared, I would say you can just leave the stream and just go. I have one person here, have one student here who has some more questions. I'll just respond to them. And if you think you're well prepared and you're not getting something new out of this, it's not a good idea to be here in the stream right now. You can go do some revision and sleep. Have a look at the questions that you've already attempted, go through them, and then make sure that you sleep well. Make duas, inshallah. Thank you, Aisha. Jazakallah. You've been very responsive in classes as well when I've been depending on you guys for calculations. You've been the one who's been responding most of the times. Thank you for that. That helped me a lot as well. All the best for your exam. I am hoping that you'll easily get an A star. Aim for that distinction as well, since you've been getting perfect scores in some papers. So you can try for that. Don't take too much stress of that though. Stress for that though. Just do your best and that will be fine, inshallah. Inshallah. Inshallah, all the best. You've prepared well now. Now make duas as well. And just be fresh before your exam, inshallah. Thank you so much, everyone. You're welcome. Make sure you don't slow down in the middle of the exam. Don't get stuck at any particular question, Batul. Just make sure you don't get stuck, and that will make sure that you have enough time at the end for doing some rechecking. If you end up getting stuck at a question in the middle, so if it's a 5 mark question and you've spent like 5 minutes on just thinking about what to do in that, that's not a good idea for the middle of the exam. Any question that you can't figure out in a couple of minutes, as in figure out means that you do not understand what method you're going to use here, what how you're going to approach that question. If you can't figure that out, make sure to move on. Do not remain stuck at that question. Do everything that you know first of all, and then the difficult questions at the end. Leave enough time for that. In the last 5 minutes, if you are stuck on a question that you can't figure out, it's a better idea to go and recheck the rest of the questions rather than spending those last 5 minutes on trying to figure out something that you've already spent some time on and you can't figure that out. Maybe you can increase 3-4 marks somewhere else in the exam where you might have done some careless errors. That's very important that you go and recheck your paper. It's okay, Aisha, it happens. I was also expecting it in my time, but it's hard, you don't even realize it and you end up doing a careless error somewhere. Just do your best and it'll be fine, inshallah. Make sure to check your exam, that's important. Because mostly when you're well prepared, the marks that you do end up losing is because of careless errors. So you need to make sure that you do proper rechecking. Leave time for that. In paper one, generally time is not an issue. So you can leave some time at the end for rechecking. For M1 and P3, that's not always true. 2024 October, November, paper 1-2 circular measure. October, November, 1-2 circular measure. This one, that's a relatively easy one, I think. It's just that they have a lot of, letters there that makes it maybe a bit more complicated. But they've given the perimeter and they've given the area. So you find your own perimeter, make an equation from that. How do you find your own perimeter? You've got some arc lengths, this arc, this arc, this arc. Find those arc lengths, add them up together. Then you have these straight edges. Add them as well. And just equate that to 14. That's the perimeter that they give us. And that they've given us here. Yep. Add all of those lengths, equate that to 14 like this. And then find the area. How do you find the area? It's 3 sectors. This is one sector. This is another sector. And in the middle, you've got another sector. Find the areas of these 3 sectors, add them up together, and equate that to 10. That's the area of the plate that they've given. You get 2 equations from that. And then you solve them simultaneously. You can see the working for this. These are the 2 equations that we get. This equation and this equation. Make one variable the subject from one equation, put that in the other equation and do substitution. So it'll work something like this. Go through this solution. It's not that complicated. Yes, this video will be available. This will be available until exam. I'll take it down after the exam because it has some content that can be subjected to copyright by Cambridge, and that would be an issue. But it will be available until the exam, yes. Uh, we talked about that earlier in the stream, increasing and decreasing function. If you look at the beginning of the stream, let me see if I can find that here. I think around 30 to 45 minutes from the start, you would find that somewhere there. You'll find it in the beginning. Okay, Abdul Hadi, let me look at those questions that you have sent as well. 2024. No, this is Cambridge. This is not at Excel. This is Cambridge. 2024, 1-3, question 10. 2024. This is the same here. Paper 1-3, question number 10. Okay, I'll quickly explain this. You've got points A and B. They have these coordinates 4, 3, and 8, -5, respectively. A circle with radius 10 passes through the points A and B. Show that the center of the circle lies in the line y equals half x minus 4. Now, it is a property. It is a property of circles that any chord that you have in a circle, its perpendicular bisector, it passes through the center of the circle. Perpendicular bisector of any chord in a circle, it always passes through the center of the circle. So in this case, we got 2 points on the circumference. One is A, the other is B. We can make a chord using those 2 points. That will be the chord AB. And using that circle property that I just mentioned, that any chord in a circle, if you were to draw a perpendicular bisector of that, that will always pass through the center of the circle. So what you do is you find the perpendicular bisector of AB, find the midpoint, find the gradient, take negative reciprocal of that, and you find the perpendicular bisector's equation, and that's what it turns out to be. Y equals half x minus 4. That's what you had to prove. The circle has to lie on this equation, on this line, because perpendicular bisector of every chord passes through the center of the circle. Okay. Okay, let me come to that. When we have that case, that the function is neither increasing nor decreasing. We also discussed that later on, but I'll show that to you again. In the second part, it says find the 2 possible equations of the circle. Now, once you get this line, you know that the center has to lie on this line. Now, you need some more information to be able to find the center. How do you do that? You've got one line. That the center lies on. That's y equals half x minus 4. You need another equation to find the coordinates of the center. How do you get that other equation? You can do something like this. You can say, let's assume the coordinates of the center are A and B. Then we know the radius of the circle. Radius of the circle is 10. We know that. Then that means if you were to find the distance of the center from any of these points, from B or A, that will be 10. They will both be 10. Now, using that, what you can do is you can figure out what this length is. The length CM, it's a right angle triangle. You know the hypotenuse. And you have an equation that looks like this. You can find the distance between AB. These are 2 points that you know. Whatever is the distance between AB, the distance for B to M will be half of that. That's not under root 40, actually, that's 2 under root 5. The complete length, using the distance formula, you find that to be under root 80, or that's 4 under root 5. Then half of that will be the length MB. Now, using this, you can find the length of CM. Using Pythagoras, you get that CM is supposed to be 4 under root 5. Okay, the length of CM is equal to 4 under root 5. And then what we can do is we can find the length of CM in terms of A and B. We've got that point. We've got the center. Use the distance formula on these 2 points. This is AB. This is 6 minus 1. Using the distance formula, you get something like this. Simplify that and equate that to 4 under root 5. Right? Because using Pythagoras, we got 4 under root 5 there. That's another equation that you got there. This is one idea. There could be another idea as well. But this is one idea. You get these two equations, you solve them simultaneously, you get the values of A and B from that, and then you just write down the equation of circle based on that. Okay, it's going to be it's a long one. I cannot do the whole thing right now. If look at the solution, let me know if you have any specific question from this. If you have any specific question on this. Any part that you do not understand from this. So let me repeat what I've done is I first of all found the length of AB. That turned out to be 4 under root 5. Half of that would be MB. That's 2 under root 5. Using this right angle triangle now, we can find the length of CM as well. Using Pythagoras, we found CM. And now, since we know the coordinates of M, we can find that that's the midpoint. It's an isosceles triangle. If you break the isosceles triangle in the middle, it makes a right angle triangle, and this point is the midpoint. So we find the distance of CM in terms of A and B and equate that to 4 under root 5. That's another equation in terms of A and B. We needed two equations. Once we have those two equations, we solve them simultaneously to find the values of A and B. Once we have them, we can write down the equation of circle using the standard form. Is that okay? It's not a standard method. It's not a standard method. So that's what happens in every single paper, that you have like 1-2 questions in which you have some parts in which you have to think on the spot, right? There's no standard way that you can learn that will work for every question like this. There will be some problems for which you have to think on the spot. So this is one of those, right? You have to basically think how to make two equations. So the idea is to make two equations. You've got one equation already. And that equation is this. You need another equation. In terms of A and B. This is one way to find out another equation in terms of A and B. And then you just solve them simultaneously to get that. I can't think of a more efficient way of doing this. Whatever it is, if there is another method that, again, that would not also be a standard method that you would have seen in other questions, it will be something new for this, new in that case as well. So those standard methods that we learn for most of those questions, they don't work here. Okay. All right, let me have a look at this question, and then we'll do the March one. Which one? I'm sorry, you have to wait there. Yeah. Which one is this? From CA to CB, that will also give you a quadratic equation. So I'm not sure how more efficient it is, but you could say find the distance CA, find the distance CB. Find both of those distances. One will not work. You have to find both of them. Find both of those distances and equate them to each other. That could be another idea. Eventually, you'll get a similar equation from that as well. The resulting equation that you get, it will be of a similar form. That would also work, but it will not reduce the working much. Achha, let me come to more questions there. Let me have a look at this first. Let me share that here. This looks like a good one. Transformation question. The diagram shows part of the graph of this. Which part of this? Which part of this?
तो इसे बी पार्ट
B part? Okay, yeah. So use the line equation with the distance equation. Yeah, that might work as well. That might work as well. Yeah, we could do that without finding the point, and then yes, that makes sense. Another curve with equation y equals f of x has a single stationary point at the point PQ. This curve is transformed to a curve with this equation. For the transformed curve, find the coordinates of the stationary point, giving an answer in terms of P and Q. Okay, now how do we think about this? What transformations are happening here? The original function was f of x, right? The original function was f of x. Have we done anything in the previous part related to this? No. The original function was f of x, and that is being transformed to minus 3 f of 1 over 4x plus 8 inside the brackets like this. Now, what are the transformations that are happening? What vertical transformations do we have and what horizontal transformation do we have? We've got one vertical transformation outside. You could call this two, that you consider it as a reflection and a stretch, or you could just say it's one vertical transformation, and that is that it's a stretch along y-axis. And we've got two horizontal transformations, stretch and a translation. Now, between vertical and horizontal, it doesn't matter whichever of them you do first. So just first think about the transformation so that you can apply them on that stationary point. Then the point is P and Q. How will that change? We'll have to think about the transformation first of all. Minus 3 outside, that's a vertical stretch. You can say it's a vertical stretch. This is just for your own thinking. Scale factor minus 3. Okay, what does that mean? The y coordinate here, that is going to get multiplied by minus 3. So PQ the q, the y coordinate, that is going to become minus 3q. Okay, so that's what we get for the y coordinate at the end. All right. What else do we have? We've got multiple horizontal transformations. Multiple horizontal transformations. One is a translation and the other is a stretch. In horizontal, we have to do opposite of BODMAS. Which one do we do first? In this form, in this format,
The
one
translation.
possibility is that you simplify this. One possibility is that you simplify this and say 1 over 4x plus 32 and then think of it. Or in this case, directly, you have to do the opposite of BODMAS. BODMAS says you do plus 8 first, but you have to do opposite of that. You do this first. So in this case, you do stretch first. You say it's a horizontal stretch, scale factor, reciprocal of this, and that's going to be 4. In horizontal transformations, the scale factor is reciprocal of this number. And then you have a translation. What will be the vector for that translation? Plus 8 means you're going left, minus 8, 0. So what about the x coordinate then? First of all, you do a stretch, scale factor 4 on this. So p becomes 4 times p. And then you go 8 units to the left. Whatever this point was earlier, it was p. That goes 8 units left. So that becomes 4p minus 8. This is what you would get from that. Does that make sense?
जी सर, आ गया, समझ आ गया.
Okay. All right. If both vertical and horizontal are happening, between horizontal and vertical, the order does not matter. As in, you can do this as well, that you do these transformations first, and then after that, you do the vertical. Because vertical is only going to affect the y coordinate, horizontal is only going to affect the x coordinate. So they are independent of each other. So between horizontal and vertical, their order does not matter. But within horizontal transformations, the order matters. Within multiple vertical transformations, the order matters. Okay, within multiple vertical transformations, you do BODMAS. Within multiple horizontal, you do the opposite of BODMAS. For horizontal, we do the opposite of BODMAS. Opposite of BODMAS. BODMAS is saying, because of the brackets, that you do plus 8 first. Because we have those extra brackets there. But you have to do the opposite of that. So that's why you do this first. Okay, all right. May 25, question 9. Okay, let me open that quickly. Question 9 from here. Okay, where would that be? Okay, just give me a second. I'm just finding that question from this recent paper that we had. Paper 1-3, June 2025. Okay, question number 9 from this. Okay, so this is question 9 from the most recent paper that we had, 313. And the second part of this. Okay, let's have a look at this quickly. This is from the same paper, June 25, paper 1, variant 3, May 25. Let's try this one. Okay, so it says the three points P, Q, and R have these coordinates -13, 5, 5, 1, and 2K, where K is a constant. It's given that the angle PRQ is a right angle. Show that one of the possible values of K is 10 and find the other possible value. Okay, so how do we think about this now? We have to find one of the possible values of K and also the other possible value. PRQ is a right angle. Okay, so how do we do that? We can say, let's find the gradient of PQ. PRQ is a right angle. The right angle is at R. Let's find the gradient of PR. What does that turn out to be? K minus 5 divided by 2 minus 13. That becomes plus 13. And you have K minus 5 over 15. That's the gradient of PR. Then you find the gradient of RQ and see what that turns out to be. Gradient of RQ, that would be K minus 1 divided by 2 minus 5. Now, since you have a right angle at the point R, PR should be perpendicular to RQ. They should be perpendicular to each other. So that means the product of their gradients is supposed to be equal to -1. Or you can say one is negative reciprocal of the other. So you can say K minus 5 divided by 15 times K minus 1 divided by -3. That should equal -1. That's the equation that you get. To solve this quadratic equation, K minus 5 into K minus 1, what does that turn out to be? K squared minus 5K minus K plus 5 multiply minus 45 on the other side, that becomes plus 45 there, and you get this quadratic equation, K squared minus 5K minus K squared minus 6K minus 40 equal to 0. Can we factorize this somehow? 40 is 10 times 4, so we can use K squared minus 10K plus 4K minus 40 equal to 0. We get two factors from this. K minus 10 and K plus 4. So K either equals 10 or it equals -4. That's the first part. The first part was fairly basic. We had to show that one possible value is 10 and the other is -4 then. And it says it's now given that K is equal to 10. A circle passes through the points P, Q, and R. Okay. So now in the second part, they're saying there's a circle. Part 2. There is a circle. And that circle passes through those points P, Q, and R. So let's mark those 3 points. P is -13. We know the value for K is 10 now. So this is going to be 10. P is -13. That will be on the left side and in the middle somewhere. So let's import this point here. This is point P. It has coordinates -13 and 5. This is one point, -13 and 5. And 5, 1, that's another point that will be on the right side somewhere and below, maybe somewhere here. Let's just mark that randomly. This is point Q, that's 5, 1. That's another point that we have. And then finally, we've got a point that is 2 and 10. 2 and 10, the angle at R should be 90 degrees. So let's mark that somewhere. That is turning out to be, let's mark that somewhere here. If that is 5 and that is 2, let's just put that here. It often helps to draw these circle diagrams relatively accurately. That helps with the thinking in the next parts. R is 2 and 10, so this is the third one. Okay, so I've marked these in a way that their coordinates make sense, that minus 13x coordinate is on the extreme left side, and then you have 2 here, and then you have 5 here. Vertically, you've got 1 here, this is 5, and this is 10, although it could be made slightly better, but you get the idea. It will look something like this. I could take this here maybe. So this is 1, this is 5, and this is 10, right? So draw it relatively accurately in relatively accurate positions. That will help you think about it better. So we got these 3 points. Now we know that the angle at the point R, that is 90 degrees. So the question says that this angle is 90. Okay, this angle is supposed to be 90. Now if this angle is 90, what does that mean? Angle at the circumference is 90. When can you have an angle of 90 at the circumference? There's only one possibility. If angle at the circumference is 90, the only possibility is that this chord PQ, this is going to be diameter, right? No other chord can make 90 degrees on the circumference. So if it has to be diameter, I'll just draw it a bit more accurately now. It looks something like this, perhaps, so that it becomes the diameter, and the center is going to be exactly in the middle. Okay, only diameter can make 90 degrees on the circumference. It says find the equation of the tangent of the circle at the point R. Give your answer in this form where A, B, and C are integers. Okay, so now we know that the center is supposed to be the midpoint of P and Q. So we can find the midpoint of P and Q. Let's call that point X. What's that going to be? Minus 13 plus 5 divided by 2, and 5 plus 1 divided by 2, and that gives us minus 8, and minus 8 over 2, that's minus 4. And 3, these are the center's coordinates. We want the equation of the tangent at the point R. Now the rest is fairly straightforward after this. Find the gradient of XR. Gradient of the tangent would be negative reciprocal of that. Put that in y minus y1 equals m into x minus x1, and you would get the result, right? The rest you can do after this. You have to find the equation of the tangent. The key part was understanding that the midpoint of PQ would be the center, because the angle that the chord PQ is making at the circumference is 90. Only diameter can make 90 degrees on the circumference. So PQ therefore has to be the diameter. And if PQ is the diameter, then its midpoint is supposed to be the center of the circle. So using the center of the circle, you can draw a radius to the point R. That will be this line. Tangent is going to be perpendicular to that. So you can find the gradient of the radius, take negative reciprocal of that, and then we find this. How do we know that the center is this? I explained that, because it's supposed to be. We do not need a circle equation here. We do not need a circle equation. It doesn't say that we need that. We just need the equation of the tangent. Right? For that, now we would just find the gradient of XR, take negative reciprocal of that. That will give the gradient of the tangent. We have a point on that line already. You can write down the equation. Okay, all right. Now let me have a look at another one from here.
सर वो एक व्हाट्सएप में क्वेश्चन भेजा था जो लास्ट आपने करवाया ना उससे पहले। तो उसका जो सी पार्ट है, बस अगर आप मुझे उसका ओवरव्यू दे देना तो मुझे समझ आ जाएगी, और वो मेरा लास्ट क्वेश्चन है। तो बस
Let me open that.
सिर्फ वो ही चाहिए, पूरा सॉल्व करने की जरूरत नहीं, ताकि मैं सिर्फ मुझे पता चल जाए।
Yeah, just give me a second. 1 minute time.
जी जी सर, यही क्वेश्चन।
इसका पिछला पार्ट
सो वो भी मैंने भेजे, ए और बी पार्ट।
जो डेरिवेटिव वाला है।
जी 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 जी, डेरिवेटिव और के इज इक्वल टू 2।
ओके ओके, so let's have a look at this now. Okay, so we're going to end in about 10-15 minutes, inshallah. Just the last couple of questions, and then we end for today. It's quite late now. Okay, let's look at this. Equation of a curve is this. You have found dy over dx, and then it's given that k is equal to 2. Find the coordinates h to point. Okay, you're done with that as well. Part C is what you're asking about. Points A and B on the curve have these x coordinates. For a different value for k, the tangents to the curve at the points for A and B meet at a point where the x coordinate is 0.6. Find this value of k. Okay, so this is the equation of the curve that we're given. Kx raised to power 1 over 2 minus 4x squared. Let me write that down here. Kx raised to power 1 over 2 minus 4x squared plus 2. That's the function that we've got. And the value of k that they gave us earlier, that's no longer relevant. Okay, so that's all that we need from the previous parts then. Find the derivative of this. You would have already done that in the first part. So I'll just do that again here quickly. It would be 1 over 2 into kx raised to power minus 1 over 2 minus 8x. That's the derivative that you get. Now they're saying there are 2 points, A and B, with these x coordinates, 0.25 and 1. The tangents at these 2 points, they meet at a point with x coordinate 0.6. Now, what do you understand from that? There's one tangent, there's another tangent. They meet at this point. This point has an x coordinate of 0.6. Now, how do you find points of intersection of two functions? You solve them simultaneously, but before that, we need those two functions. So we need the equations of these two tangents first of all. Okay, so you want to find the equations of these two tangents. How do you find them? For equation of any line, you need two things. Number one, you need a point on you need a point on this line, and number two, you need the gradient of this line. These are the two things that you need for that. Now, do we have a point? We have the x coordinate for both of those points. Can we find the corresponding y coordinates from that? We can do that in terms of k by inputting those values in the original function. And then we can find their derivatives as well. Let's do that. So we've got the function, we've got the derivatives in both of them. For both of them now, what we'll do is we'll say inside the original function, let's input x equal to 0.25. Here as well, you put x equal to 1. And in the derivative, you put x equal to 0.25 and you input x equal to 1. From this, what you would get would be the corresponding y values for them, right? You get y equal to something and you get y equal to something here. So that will give you the 2 points that you're looking for, 0.25 and whatever the other point turns out to be. From this, you'll get another point. That will be for the other tangent. When you input x equals 0.25 and x equals 1 here, from this, what you would get would be the gradients of those tangents. You'll get dy over dx equal to something. That will be the gradient of the first tangent. And from x equals 1, you will get the gradient of the other tangent. You get dy over dx equal to something. That will be the gradient of the other tangent. You would have the point, you would have the gradient, you would write down their equations, and in that you would equate them and put the value of x 0.6 there. Do you get an overview of this? I'll show you the solutions in a moment. You get
जी जी सर,
the
समझ आ
overall
गई।
idea.
जी जी,
ना
इक्वेशंस बना के दोनों ग्रेडियंट्स की, सॉरी टेंजेंट्स की, और उसमें 0.6 पुट करेंगे तो के की वैल्यू आ जाएगी।
बिल्कुल। व्हेन यू इक्वेट, आफ्टर यू इक्वेट बोथ ऑफ देम फर्स्ट, पहले उनको इक्वेट करना पड़ेगा दोनों टेंजेंट्स के इक्वेशंस को।
जी जी, ठीक है सर।
ये कौन से पेपर से? आई विल शो यू द सॉल्यूशन क्विकली एज वेल, आप मेरे को देख रहे हैं उसको।
सर ये अक्टूबर नवंबर 2024, पेपर 1 वेरिएंट 3।
1 3, okay. So you can find that here. This is the working. It becomes a bit complicated because वो k के terms में है, तो वो simplification करने, वो algebras में थोड़ा ज़्यादा हो जाता है, but that's the idea. फंक्शन के अंदर आपने इनपुट किया, x की वैल्यू 0.25 इनपुट की और x की वैल्यू 1 इनपुट की, ठीक है। और फिर आपने क्या किया, जो डेरिवेटिव था उसके अंदर आपने इनपुट कर दी वैल्यूज। डेरिवेटिव के अंदर एक दफा आपने 0.25 इनपुट किया, एक दफा 1 इनपुट किया। के ट्रम्स में आपके y कोऑर्डिनेट भी आ गया और ग्रेडियंट भी आ गया। फिर आपने y माइनस वाई वन इक्वल्स m इंटू एक्स माइनस एक्स वन से इसकी इक्वेशन लिखी और इसकी इक्वेशन लिखी। इन दोनों को इक्वेट करके x की वैल्यू जो उसने कहा था 0.6 वो इनपुट कर दिया और फिर इसको सिंप्लीफाई किया। क्वाइट सम वर्किंग, तो इसमें एरर के चांसेस थोड़े होते हैं, लेकिन
सर
दैट्स द कॉन्सेप्ट।
जी 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 सर, मैंने भी इस तरह किया। मैंने, आपने कहा ना एरर के चांसेस, मैंने पहले में ही एरर कर दिया। वो मैंने ए की वैल्यू सही नहीं लिखी, जो आपने उससे निकाला ना इक्वेशन से, वाई की वैल्यू, सॉरी, वो नहीं सही लिखी।
हम्म
मैंने वहीं पे एरर कर
हम्म।
दी। बस मुझे समझ आ गई, ठीक है। थैंक यू सर, थैंक
चलिए
यू सो
गुड।
मच, थैंक यू सो मच। बस आप दुआ करेंगे अब आप कल के पेपर के लिए। एंड बस अब अल्लाह अल्लाह ही मालिक है। मैंने तो अपनी पूरी तैयारी की।
इंशाल्लाह, इंशाल्लाह बेस्ट ऑफ लक, इंशाल्लाह अल्लाह ताला बेहतर करेंगे।
ठीक है, थैंक यू
मेक
सो
श्योर यू
मच।
स्लीप वेल, इंशाल्लाह।
जी जी
सी
जी,
यू
मैं
इंशाल्लाह।
बस नहीं लगा
अल्लाह,
सर। अल्लाह हाफिज़।
ऑल द बेस्ट, अल्लाह हाफ़िज़। अच्छा, any other questions? May June 24। अच्छा, we are about to end now. uh, we are about to end now. May June 24 paper 1 1। अच्छा, अब जो बाकी आप questions कह रहे हैं ना, what I'll do is I'll just show you the solutions quickly. I'll explain them quickly और फिर आप उसको देख सकते हैं. You can take snapshots of the solution and have a look at them in your own time then, because I will be ending the stream now. I might be posting some solutions, uh, posting some videos for difficult questions from some recent papers for different topics, maybe function transformations and circle equations. If I manage to stay up for a bit more, I might do that. You can find those uh, in the morning when you wake up. So you might find some of these questions that you're asking about there in those videos. It's just about to end. It's just about to end in a few minutes. Logic behind which question? I'm sorry, I missed that chat earlier. Logic behind what? Okay. अच्छा, मई जून 24 पेपर 1 1 ये देखते हैं। जून 24 पेपर 1 1, इसमें क्वेश्चन 11 पार्ट बी। Okay, so it's quite long working, and you will see 2 3 questions like this in the recent papers, जहाँ पे वो कहते हैं कि एक आपका एक आपका जो होता है टेंजेंट है और एक नॉर्मल है, और उससे आपकी एक ट्रायंगल बनती है, उस ट्रायंगल का एरिया निकालें। Now, let's look at the question statement. They're saying a triangle is bounded by the y-axis, the normal to the curve at the point where x is equal to 1, and the tangent to the curve at the point where x is equal to -1. Find the area of this triangle. Find the area of this triangle. Now, how do we do that? अब क्या क्या बात की हुई है उसने, पहले उसको ब्रेक डाउन करें। उसने कहा है एक ट्राइंगल है वो y एक्सिस से बाउंडेड है एक तो, ठीक है. सो वन साइड ऑफ दैट ट्राइंगल हैज टू बी द y एक्सिस. ओके, वो नीचे हो सकता है, ऊपर हो सकता है, वी आर नॉट श्योर अबाउट दैट, इट कुड बी एनीवेयर. y एक्सिस एक साइड है उस ट्राइंगल की. एक और साइड है नॉर्मल टू द कर्व एट द पॉइंट व्हेन x इज इक्वल टू 1. और फिर एक और साइड है tangent to the curve at the point where x is equal to -1. So first of all, what you do is you find these two equations. Equation of the normal when x is 1 and equation of the tangent when x is -1. You find these two equations, equation of the normal and equation of the tangent. How do you do that? Like you do normally, you've got the function, you find the derivative for that. Derivative निकाल लिया आपने. Derivative के अंदर आप एक दफा x की वैल्यू 1 इनपुट करें, that gives you -9. Okay, now that's the gradient of the curve at that point. What about the gradient of normal? That will be negative reciprocal of that. That becomes 1/9. Then you write down then you find the corresponding y coordinate of that point when x is equal to 1. What's the corresponding y coordinate? That turns out to be 3. So now you have a point on that normal, that's 1, 3, and you have the gradient of the normal, and you get the equation of the normal. So that's one thing. Then you find the equation of the tangent. What would that be? You're given that x is equal to -1. You input x equals -1 in the function and in the gradient and in the derivative. Derivative gives you -9. That means the gradient of the tangent at that point is also going to be -9. What about the y value of the function? You input x equals -1 in the function, and that gives you a y value for 1. So the point that you get is this, -1, 1, and the gradient is -9. You write down the equation of this line as well. So अब क्या हुआ आपके पास? Equation of line भी आ गई, equation of normal भी आ गई. Normal भी आ गई और equation of tangent भी आ गई. ये दो चीजें चाहिए थी आपको, ठीक है. Now you want to find the area of this triangle. Now think about this. I've drawn this here. Normal at the point when x was equal to 1, this is x equals 1, and grade tangent at the point when x is equal to -1. So x equals -1, I mark that somewhere here. That's x equals -1. So I've sketched this just to understand what it looks like. Okay, it does not have to be very accurate, the drawing that you do, but uh, just to understand what it's going to look like. One side is tangent, one side is the normal, another side is the tangent. And the third side is the y-axis. This is the equation this is the triangle that we get in the middle. We want to find the area of that triangle. Now, how do you find the area of that triangle? That's the question. How do you find that area? You can use half into base into height. How would you do that? You would have to figure out this point where the normal meets the y-axis, so y-intercept of the normal. And you would need to find this point here where the tangent meets the y-axis, the y-intercept of the tangent. Once you have these 2 points, you can find this length from them, right? So that's what I've done next. You have the equation of the normal and the tangent. You put x equals 0 in both of them. That gives you the y-intercept for them. 26/9 and -8. Okay, so we get the y-intercept. Y-intercept turns out to be -8 for the tangent, 26/9 for the normal. अब जब मैंने ट्राइंगल बनाई है यहाँ पे, उसमें मेरे पास मैंने नीचे शो किया हुआ है इसको. अगेन इट डजंट मैटर, कैलकुलेशन से हमें पता चला कि असल में ये वाला पॉइंट जो था ना, ये एक्स एक्सिस के ऊपर था. बट दैट्स ओके, हमने सिर्फ समझने के लिए बनाई डायग्राम, एंड वी गॉट दिस, दैट्स ओके. बेस क्या होगी अब इस ट्राइंगल की? जो वर्टिकल साइड है, वी कैन कंसीडर दिस द बेस ऑफ द ट्राइंगल. एंड देन हाइट इज गोइंग टू बी परपेंडिकुलर टू दैट. हाइट होगी बेस के साथ जो थर्ड पॉइंट से जो बेस पे परपेंडिकुलर आ रहा है वो हाइट होगी। तो बेस की लेंथ कितनी होगी, -8 से लेकर 26/9 तक। जस्ट फाइंड देयर डिफरेंस, दैट विल गिव यू दिस बेस। 26/9 माइनस -8, दैट गिव्स यू सम वैल्यू हियर 98/9। ये आपकी बेस होगी। अब इस तरह की ट्राइंगल है, देखें जो राइट साइड पे यहाँ पे बनाई है, ये साइड कितनी हो गई है, ये हो गई है 98/9, ये बेस की लेंथ हो गई। what would the height be then? If you're taking this side as the base, height is going to be the perpendicular to that, ये height होगी। अब इस height के लिए क्या चाहिए हमें, look at that diagram again। height के लिए हमें ये point of intersection चाहिए normal और tangent का, right? उससे हमें height मिल जाएगी। पॉइंट ऑफ इंटरसेक्शन, ये वाला पॉइंट चाहिए कि कौन सा पॉइंट है। हाउ डू यू फाइंड पॉइंट ऑफ इंटरसेक्शन ऑफ दोस टू फंक्शंस, उनको साइमल्टेनियसली सॉल्व करना। तो ये सॉल्व किया हमको साइमल्टेनियसली। ये नॉर्मल की इक्वेशन थी, ये टेंजेंट की इक्वेशन थी, इनको साइमल्टेनियसली सॉल्व किया। we got x equals -49/41 from this. That's the x coordinate of the point of intersection of these two lines. इसका मतलब ये हुआ कि जो ये वाला पॉइंट है, इसका x कोऑर्डिनेट क्या हुआ, -49/41। So what is this distance then from the origin? ये कितना distance हो गया? This is 49/41. We would consider that as the height of this triangle. 49/41. This would be considered the height of the triangle. So now we can see we have a triangle like this, and in this triangle, 49/41 is the height of the triangle. 98/9 is the base of the triangle. We use the formula half into base into height, and that gives us the area. That's 6.51. That's the final result that we get. Okay, I'll show you the complete working. आप ये देख सकते हैं, you can take a snapshot of this, have a look at this in your own time. This is the first page. It's a fairly complicated question, quite complicated. You would need quite some time to be able to think about this. That's why it's important that you make sure you don't get stuck in the paper in the middle somewhere. कोई दरमियान में कोई मुश्किल क्वेश्चन पे ऐसा मिलता है जिस पे आप स्टक हो गए हैं, कुछ नहीं समझ आ रही, मेक श्योर टू मूव ऑन, because otherwise you would not have enough time left at the end to be able to figure out these more difficult questions. तो जो आप फर्स्ट गो में होते हैं वो क्वेश्चंस करें, और फिर दोबारा से जो सहायता के सारे क्वेश्चंस आपको आते हैं जो हो रहे हैं आराम से, वो तो आप कर लें। उसके बाद फिर एट द एंड यू विल लुक एट द मोर डिफिकल्ट क्वेश्चंस। तो ये आपका फर्स्ट पेज है, इफ यू वांट टेक स्नैपशॉट ऑफ दिस यू कैन डू दैट। ये फर्स्ट पेज है, वो द फर्स्ट पार्ट था। दिस इज द सेकंड पार्ट, पार्शियल वर्किंग फॉर दैट, जिसमें हमने नॉर्मल और टेंजेंट की इक्वेशन निकाली और उनको इक्वेट करके उनका पॉइंट ऑफ इंटरसेक्शन निकाला। And then here we found their y-intercepts, and then we found the area of the triangle using that. Okay, it was quite complicated, but that's how you would do that. You can also use the shoelace method. Yes, you can do that, but it would not reduce your working by much. You can use that, but it's all the other working lambi hogi. It's always easier to use half into base into height whenever you have one side of the triangle that is either vertical or horizontal. तो जो भी vertical या horizontal side होती है ना, उसको हम base ले लेते हैं, and that makes it so much simpler to find the area directly. Otherwise, using shoelace method, you would have to do all of this. That you would need these points anyway. You would need this point as well. And then at the end, instead of this, you use the shoelace formula that will even make your working longer than this. But that works, yes. You can do that as well. That will work. Okay. Okay, just give me a second. What I'll do now is I'll just answer some general questions and then we end. Okay. Let this question not demotivate you. This will be like one question out of 11, 12 questions. So it's okay. You will do as much as you can. You'll do as much as you can. जो बाकी पेपर आते हैं वो तो करेंगे उसके बाद फिर इसमें आप जितने पार्ट्स मार्क्स देंगे उतना हो जाएगा बाकी थ्रेशोल्ड विल टेक केयर ऑफ दिस इस पेपर का थ्रेशोल्ड भी जो है वो इतना हाई नहीं होगा फिर ये वाला क्वेश्चन एंड करे तो Obviously, my kids have stormed into the room as well. They're not going out, so that means we're going to be ending soon now. Okay. I'm just going to be answering some general questions now. कोई question अगर आपको specific है तो वो मैं उसका आपको solution दिखा दूंगा and you can just go through that. अच्छा. Multiple transformations were to add them to the given equation in a specific order. Here we already talked about the order of transformations earlier in the very beginning. In the very beginning, we talked about order of transformations. Vertical transformations के लिए you follow BODMAS. Horizontal transformations के लिए you do opposite of BODMAS. Okay. Vertical के लिए you do BODMAS. Horizontal के लिए opposite of BODMAS. Major P13 dy over dx less than 0. Okay, y decreases. इस तरह की जो statement होती है ना, we talked about this earlier as well. If the question says y decreases as x increases, what that means is, think about the x and y axes. This is what they look like. ये x है, ये y है. As you go to the right, the y value goes down. That means the function is going down like this. It could be any shape. It could be like this. It could be like this. Whatever it is, the gradient is negative, right? Gradient negative होगा. जब gradient negative है तो आप कह सकते हैं it's a decreasing function. So dy over dx will be less than 0 for that reason. अगर x increase कर रहे हैं यानी जैसे आप right side पे जा रहे हैं तो y decrease कर रहे हैं यानी आप नीचे जा रहे हैं, right पे जा रहे हैं और नीचे जा रहे हैं. So इस तरह की curve होगी, downward sloping. Gradient negative होगा. जब gradient negative है तो derivative negative होगा. तो dy over dx को less than 0 कर देंगे हम उसको. ठीक है. अच्छा, अगर यहाँ पे होता कि y इंक्रीजिंग है as x increases तो फिर हम कहते हैं कि वो इंक्रीजिंग फंक्शन है, उसमें डेरिवेटिव पॉजिटिव होता. ठीक है. और मैं डिफिकल्ट क्वेश्चंस की मैं कोशिश करता हूँ कि मैं एक दो वीडियोस पोस्ट कर दूँ ऑन सर्कल इक्वेशंस एंड मे बी फंक्शन ट्रांसफॉर्मेशंस and what else, function transformations club or console. So from the last 4 or 5 years I will try if I can work in the next couple of hours to post the difficult questions from some topics. So I'm thinking of function transformations and equation of circle. Any other topic apart from that? I think these three are going to be fine. इसके अलावा और तो किससे बहुत मुश्किल क्वेश्चन नहीं आते. डिफरेंशिएशन का बस ये जिस तरह ट्रायंगल वाले क्वेश्चन 2-3 मुश्किल है, बस और तो इतना खास मुश्किल नहीं है इसके अंदर. और इसके अलावा और कौन सा टॉपिक हो सकता है? I think the rest is fine. So I'll try if I can post that if I don't sleep too soon. Let's see. I have a lot of questions on my WhatsApp right now as well that I have to answer to. So my students at school and for the crash course past paper session, they have sent so many questions as well. I need to be responding to them. But I'll see if I can make a couple of videos and post them, which if you want, you can have a look at them in the morning. It's all right. If you're prepared well, just make dua and make sure that you stay relaxed. Panic nahi karna, bas inshallah you'll do well. If you're prepared well, you get the reward of that effort. Don't worry about that. आपने अपने बस वो करना होता है, whatever is in your control. Then you leave the rest to Allah subhanahu wa ta'ala, and then whatever happens, it's for your own good. Even if after doing a lot of preparation, what लेट्स सपोज किसी का, आपका नहीं, किसी और का, किसी का भी ऐसा होता है कि उसका पेपर अच्छा नहीं होता, लॉन्ग टर्म में उसके पीछे कुछ ना कुछ जो है ना बेहतर ही होता है, विच यू डोंट रियलाइज एट दैट पॉइंट, एंड बट आफ्टर अ फ्यू इयर्स यू ऑफन रियलाइज कि अच्छा वो आपके साथ जो भी हुआ वो लॉन्ग रन में कितना आपके लिए अच्छा हुआ. So it's okay. You have done your effort. That's all that matters. Now leave the rest to Allah subhanahu wa ta'ala, and that will be good. You'll do well, inshallah. How do we show if a curve is below or above the x-axis? Always above the x-axis, or always below the x-axis? आप मिनिमम पॉइंट फाइंड कर लें कर्व का. अगर मिनिमम पॉइंट एक्स एक्सिस के ऊपर है तो इसका मतलब है कि पूरी कर्व जो है वो एक्स एक्सिस के ऊपर है. अगर वो यू शेप्ड कर्व है, फॉर एग्जांपल, अगर नॉर्मली क्वाड्रेटिक फंक्शन में पूछता है वो, अगर वो एन शेप्ड कर्व है तो उसका अगर मैक्सिमम पॉइंट एक्स एक्सिस के नीचे है, यानी मैक्सिमम पॉइंट जो है उसकी वाई, उसका वाई कोऑर्डिनेट नेगेटिव है, तो उसका मतलब होगा कि वो पूरी की पूरी कर्व एक्स एक्सिस के नीचे है. राइट, सो वन ऑफ दोस टू थिंग्स. ठीक है, आई थिंक वी आर गोइंग टू एंड हियर, अदरवाइज आप लोगों का टाइम इसमें वेस्ट होगा. देयर इज नथिंग प्रोडक्टिव दैट वी आर डूइंग नाउ, doing any more now. So we will end this now. Show the solution of question 10 part B, October November 24 paper 1-3. Okay, let me quickly do that. कन्वर्जेंट का मतलब होता है कि वो जीरो की तरफ अप्रोच कर रहा है, जीरो को कन्वर्ज कर रहा है. कन्वर्जेंट का आप बस डायरेक्टली ये समझेंगे, उसके रेशियो जो है ना वो -1 और 1 के दरमियान में होगी. कन्वर्जेंट सीक्वेंस है तो उसकी रेशियो -1 और 1 के दरमियान में होगी. बस ये इसका मतलब होता है, रेशियो -1 1. जो सम टू इन्फिनिटी की कंडीशन होती है वही कन्वर्जेंट की कंडीशन होती है कि सम के रेशियो -1 और 1 के दरमियान में होती है. ये सोल्यूशन आप देख लें, वैसे हमने पहले भी किया था ये. This is one way to do this. You can have a look at this. ये हमने दरमियान में किया भी था सवाल, आपको कहीं स्ट्रीम में दरमियान में मिल जाएगा. जी जी बिल्कुल, कन्वर्जेंस की सिग्निफिकेंस है. अगर आपकी रेशियो मल्टीपल सॉल्यूशंस आ रहे हैं, उसके मल्टीपल सॉल्यूशंस आ रहे हैं अगर आपके पास, तो रेशियो जिसकी -1 और 1 के दरमियान में है, जो -1 और 1 के दरमियान में है वो आप कंसिडर करेंगे. जो -1 और 1 के बाहर है उसको नहीं कंसिडर करेंगे. मैंने आपको अभी बताया, मैं आपको दिखा देता हूँ वो, केस वर्बली जो है वो इतना क्लियर नहीं है. Arithmetic and geometric progressions. If you have a convergent series, all that means is this, कि वो वैल्यूज छोटी होती जा रही हैं और जीरो का अप्रोच कर रही हैं, जीरो का अप्रोच कर रही हैं, और उसकी जो रेशियो होगी वो -1 और 1 के दरमियान में होगी. -1 और 1 के दरमियान. ठीक है, ठीक है, -1 और 1 के दरमियान में होगी. सम टू इन्फिनिटी की भी यही कंडीशन होती है और कन्वर्जेंट की भी यही कंडीशन होती है. November 24th, Safi. Okay, let me show that to you. Paper 1-2, question 9. 1-2, question number 9. Question 9, part A. So you have this function and this line. एक पॉइंट ऑफ इंटरसेक्शन उसने बता दिया और उसने कहा कि के और पी की फाइंड वैल्यूज फाइंड करें और दूसरा पॉइंट ऑफ इंटरसेक्शन निकालें। एक लाइन है, दूसरा एक क्वाड्रेटिक फंक्शन है। इसका क्या मतलब है? अगर एक सोल्यूशन है इनका सिर्फ, इफ दे, अच्छा नहीं, एक सोल्यूशन नहीं है, सॉरी, एक सोल्यूशन नहीं है, उसने आपको ये बताया हुआ है कि ये दो फंक्शंस है और एक पॉइंट ऑफ इंटरसेक्शन बताया हुआ है उसने। इसका मतलब ये है कि अगर आप इन दोनों को सॉल्व करना शुरू करें, अगर इनको इक्वेट करें, इनको साइमल्टेनियसली सॉल्व करना शुरू करें, तो जब सॉल्व करेंगे तो अगर वो पॉइंट इनपुट करते हैं इसके अंदर, तो वो सेटिस्फाई करना चाहिए उस इक्वेशन को। another way to think about this is दोनों के अंदर वो पॉइंट इनपुट कर दें, जैसे मैंने यहाँ पे किया है, दोनों के अंदर वो पॉइंट इनपुट करें, क्योंकि वो पॉइंट ऑफ इंटरसेक्शन है, वो दोनों इक्वेशन को सेटिस्फाई करना चाहिए। वो इसको भी सेटिस्फाई करना चाहिए, इसको भी सेटिस्फाई करना चाहिए, राइट? क्योंकि वो दोनों इक्वेशंस पे दोनों फंक्शंस पे लाया करता है। उन